There are maps that should not exist. Not forgeries, not fantasies, not the crude guesswork of sailors sketching coastlines from memory. These are charts of astonishing precision, drawn centuries before the instruments that could have made them possible, depicting lands their makers never visited, coastlines their civilizations never charted, and in some cases, terrain that would remain hidden beneath miles of ice for thousands of years after the last cartographer set down his pen. They hang in museums now, these impossible documents. They rest behind glass in temperature-controlled archives, studied by scholars who cannot explain them, dismissed by skeptics who cannot account for their accuracy, and quietly ignored by a mainstream that finds their implications too unsettling to address. Yet the maps remain. The measurements hold. The projections, when tested against modern satellite surveys, align with a precision that defies every assumption we hold about the limits of ancient knowledge. How did a Turkish admiral in 1513 draw the Antarctic coastline as it appears beneath the ice, a coastline that would not be confirmed until seismic surveys in 1958? How did a 14th century Venetian expedition produce a map of Greenland's subglacial rivers, channels that lie buried under 2 miles of glacial ice, invisible to any eye, inaccessible to any probe until the advent of ice-penetrating radar in the late 20th century? How did an 18th century French cartographer render the landmass beneath Antarctica's frozen shell with a fidelity that modern geologists find unnervingly precise? These are not comfortable questions. They do not lead to comfortable answers, yet the maps exist and they demand engagement. Not belief, not credulity, but engagement. The willingness to hold contradiction in the mind. The patience to trace the evidence where it leads, even when that destination lies outside the orderly boundaries of conventional history. Sit back, let the light dim, let the present moment recede, and allow the ancient world to draw closer. For the next hours, we journey through 8 cartographic mysteries that span continents and millennia, from the clay tablets of Babylon to the woven stick charts of the Pacific, from the medieval monasteries of Europe to the palace workshops of the Ottoman Empire. Each case presents the same troubling pattern. Knowledge appearing before it should have been possible, precision exceeding the tools available, and a silence in the historical record where explanation ought to stand. The Earth remembers what we have forgotten. The maps are its testimony, waiting for those patient enough to read them. The year is 1929. A German theologian named Gustav Adolf Deissmann works in the Topkapi Palace Library in Istanbul, cataloguing documents that have gathered dust since the collapse of the Ottoman Empire a decade earlier. The collection is vast, chaotic, the accumulated papers of 5 centuries of imperial administration. Treaties, decrees, letters, ledgers, and among them, folded and forgotten, a fragment of gazelle skin bearing a map unlike anything Deissmann has ever seen. The parchment measures roughly 90 by 60 centimetres, its edges ragged where it has been torn from a larger original. The colours remain vivid despite 4 centuries of storage. Coastlines traced in red, interior features marked in brown and green, the ocean studded with illustrations of ships, sea monsters, and compass roses. Latin annotations crowd the margins, and near the top edge, in careful Ottoman script, appears a signature and a date. Piri Reis, Admiral of the Ottoman fleet, the year 1513 of the Common Era. Deissmann recognises the name. Piri Reis, Piri the Admiral, was a legendary figure in Ottoman naval history, nephew to the famous corsair Kemal Reis, veteran of countless Mediterranean engagements, author of the comprehensive naval atlas known as the Kitab-ı-Bahriye. His charts were renowned for their accuracy, his knowledge of coastlines and currents unmatched in his generation. Yet the map Deissmann holds does not depict the familiar waters of the Mediterranean or the Black Sea. It shows the Atlantic Ocean and the coasts beyond. Europe, Africa, and the Americas, barely 2 decades after Columbus first made landfall in the Caribbean. The map creates immediate scholarly interest when Deissmann publishes his discovery. Here is evidence of Ottoman engagement with the New World far earlier than previously documented, proof that Turkish cartographers were synthesizing Portuguese and Spanish discoveries within years of their occurrence. But as researchers examine the document more closely through the 1930s and 1940s, a deeper puzzle emerges. The map shows more than it should. It shows things Piri Reis could not have known. The coastline of South America appears with remarkable fidelity. its eastern shore sweeping southward through the bulge of Brazil, the indentation of the Rio de la Plata, the narrowing toward Patagonia. Conventional history records that this coastline was not fully explored until Magellan's voyage of 1519 to 1522, 6 years after Piri Reis completed his chart. The rivers of the Amazon basin appear in their correct positions, draining eastward from mountain sources, though Portuguese exploration of the interior would not begin for another century. And at the bottom of the surviving fragment below the tip of South America appears a coastline that should not exist at all. It curves eastward, studded with bays and mountains and what appear to be river mouths, continuing beyond the edge of the torn parchment. For decades, scholars debated what this coastline represented. Some argued it was simply the South American coast distorted by projection errors, folded back upon itself through cartographic convention. Others suggested it depicted an imagined southern continent, the Terra Australis of medieval legend. The map's own annotations seem to support conventional reading. One note describes the coast as very hot, suggesting tropical latitudes rather than polar regions. Then, in the 1950s, a cartographic analyst named Arlington Mallory began a systematic comparison of the Piri Reis map against modern surveys. Mallory was an expert in medieval map-making, familiar with the various projection systems and conventions used by Renaissance cartographers. Working with the cooperation of the United States Navy Hydrographic Office, he attempted to reconstruct the original projection Piri Reis had employed. What emerged from this analysis would spark decades of controversy. According to Mallory's findings, the mysterious southern coastline matched with startling precision the actual shore of Queen Maud Land, Antarctica. Not as it appears today, buried under a mile of glacial ice, but as it would appear if that ice were removed. The bays corresponded to bays confirmed by seismic survey, the mountains aligned with subglacial ranges detected by ice-penetrating radar. The rivers matched drainage channels that had not flowed with liquid water for thousands of years. The implications were staggering. If the Piri Reis map depicted Antarctica's true coastline, that coastline could only have been surveyed at a time when the ice was absent, or at least dramatically reduced from its present extent. Geological evidence suggests Antarctica's coast last stood free of ice somewhere between 6,000 and 15,000 years ago, at the end of the last glacial period. Yet the map was drawn in 1513, compiled from sources the admiral himself acknowledged were ancient, including charts he claimed dated to the time of Alexander the Great. Mainstream cartographic scholarship rejected Mallory's interpretation. The projection theory was flawed, critics argued. The coastline could be explained as a conventional depiction of an imagined southern continent, or as a continuation of the South American coast displaced by copying errors across generations of source maps. The resemblance to Antarctica was coincidental, pareidolia, the human tendency to see meaningful patterns in random data, yet the precision persisted. Charles Hapgood, a historian of science at Keene State College in New Hampshire, undertook an exhaustive analysis of the map in the 1960s, employing teams of students to test every proposed explanation. His findings, published as Maps of the Ancient Sea Kings, concluded that the Piri Reis map appeared to be based on a sophisticated source projection that correctly depicted the spherical Earth, a projection that assumed the cartographer understood the planet's circumference with an accuracy not matched in Europe until the 18th century. More troubling still, Hapgood's analysis suggested the original source map had been centered not on the Mediterranean, as one would expect from a Greek or Phoenician origin, but on a point in Egypt near the ancient city of Syene, modern Aswan. This was precisely the location where Eratosthenes had conducted his famous measurement of the Earth's circumference in the 3rd century BCE, a measurement that proved remarkably accurate and that required astronomical and mathematical knowledge far beyond what we typically attribute to the ancient world. Could there have existed in deep antiquity a civilization capable of accurately surveying coastlines across hemispheres? Could that knowledge have been preserved through the chaos of collapsing empires, copied and recopied by hands that no longer understood what they transcribed, until fragments surfaced in the libraries of medieval sailors and Renaissance admirals? The Piri Reis map does not answer these questions. It merely poses them with an insistence that refuses to fade. The parchment hangs today in the Topkapi Palace Museum, silent behind its glass, the torn edges hinting at a larger original that may lie undiscovered in some unexamined archive, or may have crumbled to dust centuries ago. The controversy it ignited continues, unresolved, the evidence pointing in directions that conventional history cannot follow, toward knowledge that appeared before its time, from sources that history has not recorded. The mystery does not close. It opens further, inviting speculation, demanding caution, rewarding neither certainty nor dismissal. The coastline remains, traced in faded red, depicting a shore that lay buried under ice before the first stone of the pyramids was laid, if the analysis is correct. And if it is not correct, then how did a Turkish admiral, working from sources he did not fully understand, produce by coincidence a chart that matches Antarctic topography with such uncomfortable precision? The ground remembers what we have forgotten. Sometimes it is not ground at all, but ice, miles deep, sealing secrets that only radar and seismic waves can now retrieve. And sometimes those secrets emerge not from scientific instruments, but from gazelle skin and ancient ink, maps that should not exist, carrying knowledge that should not have been possible. The first mystery remains open, but the journey has only begun. From the archives of Istanbul, we travel north and west, across the Mediterranean and the European continent, to a land of mist and glaciers, to an island that the medieval world knew through rumour and legend before it knew through direct encounter. Greenland, the great white mass that Eric the Red named with deliberate irony, hoping to attract settlers to a shore that was anything but green, stands at the threshold of the known world, a frontier that sailors approached with prayers and left with relief when they left at all. And upon this island, in the late 14th century, two Venetian brothers claimed to have made discoveries that would not be confirmed for 600 years. The document known as the Zeno map first appeared in print in 1558, published in Venice by a descendant of the brothers who claimed to have made the original voyage. Niccolo and Antonio Zeno, the account stated, had sailed to the far north in the 1390s, reaching Iceland, travelling onward to Greenland, and possibly venturing as far as the coast of North America itself, a full century before Columbus set foot in the Caribbean. They had produced charts of their discoveries, detailed maps showing coastlines and interior features, and these charts had been preserved in family archives until their 16th century publication. Scholars immediately questioned the narrative. The account contained inconsistencies, geographical confusions, islands that could not be located on any modern chart. The map accompanying the text showed familiar features distorted or misplaced, suggesting either poor copying or outright fabrication. Many historians dismissed the Zeno map as a Renaissance hoax, an attempt by a minor Venetian family to claim priority in Atlantic exploration, to assert that Italian navigators had preceded the Spanish and Portuguese into the Western Ocean. The dismissal was premature, for when modern cartographers examined the Zeno map's depiction of Greenland, they found something that fabrication could not explain. The map showed the island's interior crossed by a network of waterways, channels and rivers that had no correspondence to Greenland's visible geography. The ice sheet that covers nearly the entire island presents a smooth, unbroken surface. There are no rivers in the conventional sense, no waterways that a 14th century explorer could have observed or charted. Yet when ice-penetrating radar surveys began mapping the topography beneath Greenland's ice, in the 1940s and 1950s, a network of subglacial channels emerged, ancient river valleys carved into the bedrock before the ice descended, preserved in the geology but invisible to any eye, inaccessible to any instrument before the advent of modern remote sensing. And this network matched, with disturbing fidelity, the waterways depicted on the Zeno map. The correspondence is not perfect. The Zeno map contains errors, distortions, features that do not align with modern surveys. Yet the basic pattern, the positions of major drainage channels, the orientation of river systems, the relationship between highlands and lowlands, matches what we now know lies beneath 2 miles of ice. How did 14th century Venetians, sailing in wooden ships with magnetic compasses and sounding leads, chart topography that would not be visible for another 6 centuries? The conventional explanation suggests coincidence or misinterpretation. The Zeno brothers, if they visited Greenland at all, might have encountered seasonal meltwater rivers or coastal features that bore some resemblance to the subglacial channels. The similarities are exaggerated by confirmation bias, by the human tendency to emphasize matches while ignoring discrepancies. The map in this reading is essentially a lucky guess, or a projection of European river geography onto an unfamiliar landmass. Yet the counter-argument persists. The Zeno map depicts not surface features, but subsurface ones, channels that cannot form in ice and that follow the contours of buried bedrock. The match is not one of general resemblance but of specific correspondence, particular channels appearing in particular positions, draining in particular directions, connected by tributaries that align with mapped geology. Coincidence cannot explain such precision, and fabrication makes even less sense. Why would a 16th century forger invent imaginary rivers that happen to match terrain that would not be discovered for 400 years? The same troubling possibility emerges as with the Piri Reis map. Were the Zeno brothers working from sources older than themselves? Did they possess charts derived from an earlier age, when Greenland's ice was less extensive, or absent entirely? Geological evidence indicates that Greenland was substantially ice-free during interglacial periods, most recently between about 125,000 and 115,000 years ago, though reduced ice coverage may have occurred during the Holocene climate optimum around 6000 BCE. If maps existed from those epochs, passed down through unknown channels, they might preserve geographic knowledge that seemed inexplicable to medieval navigators, yet accurately depicted ancient conditions. This hypothesis raises more questions than it answers. Who could have surveyed Greenland during ice-free periods? How could such surveys have been conducted, preserved, and transmitted across millennia of climate change and cultural upheaval? What became of the civilization capable of such achievements, and why does no other trace of it remain in the historical or archaeological record? The Zeno map offers no answers. It merely complicates the question, adding another document to the portfolio of impossible cartography, another chart depicting knowledge that should not have existed, precision that exceeds the instruments available, and a silence where explanation ought to sound. The waterways flow beneath the ice, patient and unchanging, as they have flowed since the glaciers descended. The map records them, as if someone, sometime, saw them clearly, or as if coincidence has played a trick so elaborate it approaches the miraculous. Standing at the edge of the Greenland ice sheet, one feels the weight of frozen time pressing down. The ice is not static. It groans and shifts, carving icebergs into the northern seas, concealing and revealing, erasing and preserving. Beneath its surface, the bedrock holds memories older than human civilization, river valleys carved by water that flowed before Homo sapiens walked the earth. And on an old Venetian map those valleys appear, traced by hands that could not have seen them, recorded by knowledge that should not have been. The mystery does not close. It multiplies. From Venice we turn to Paris, to the salons and academies of 18th century France, where the Enlightenment blazed with confidence in reason, in measurement, in the power of human understanding to illuminate every shadow of the natural world. Here, in the heart of European intellectual life, another cartographic puzzle emerged, one that would link the Piri Reis map, the Zeno chart, and the question of Antarctic ice into a single, troubling constellation. Philippe Boitier was the first royal geographer of France, a position that placed him at the apex of cartographic authority in one of Europe's most powerful nations. His maps were renowned for their precision, his methods rigorous, his reputation unimpeachable. In 1737 he presented to the French Academy of Sciences a map that would spark immediate controversy and lingering doubt. The Boitier map depicted Antarctica, or rather, it depicted what Boitier believed lay beneath Antarctica's ice. The continent appears not as the solid white mass we know from modern atlases, but as two distinct land masses separated by a frozen sea. The western mass, roughly triangular, occupies the position of the Antarctic Peninsula and West Antarctica. The eastern mass, larger and more irregular, corresponds to East Antarctica. Between them, where the modern transantarctic mountains divide the continent, Boitier's map shows open water, a waterway connecting the Ross Sea to the Weddell Sea, bisecting the polar landmass into separate islands. For centuries, Boitier's map was dismissed as speculative fantasy. Antarctica was not confirmed as a continent until the 19th century, and early explorers found nothing but unbroken ice stretching to the horizon in all directions. The idea of a waterway through the interior seemed absurd, a cartographic fiction born of insufficient data. Then came the International Geophysical Year of 1957-1958, when scientists from multiple nations undertook the most comprehensive study of Antarctica ever attempted. Using seismic soundings, they mapped the bedrock beneath the ice sheet, penetrating miles of frozen water to reveal the continent's true topography. What they found was astonishing. West Antarctica is not a solid landmass at all. Beneath the ice lies an archipelago, a cluster of islands whose peaks form the mountain ranges visible above the surface. The West Antarctic ice sheet sits upon bedrock that lies well below sea level in many places. If the ice were removed, the sea would flood the region, creating a maze of islands, peninsulas and waterways. East Antarctica, by contrast, rests on a single continental mass, its bedrock mostly above sea level, forming a true landmass. And between them, precisely where Boache drew his waterway, the trans-Antarctic mountains rise. But they rise from a bedrock depression that, without ice, would indeed form a connecting sea. The topographic divide between East and West Antarctica corresponds closely to the passage Boache depicted. His two landmass configuration, dismissed for 2 centuries as fantasy, reflects the actual subglacial geography with remarkable fidelity. Boache himself acknowledged that his map was based on conjecture and earlier sources. He was attempting to synthesize reports from explorers who had glimpsed the southern ice, combining their fragmentary observations with theoretical reasoning about continental distribution. The Enlightenment mind sought symmetry, balance. If great land masses existed in the northern hemisphere, logic suggested corresponding masses in the south. Boache may have simply guessed correctly, his theoretical projection happening to match reality by chance, but the precision troubles that explanation. Boache did not simply posit a southern continent, he depicted its internal structure, the division between east and west, the connecting waterway, the relative positions of the component landmasses. For pure conjecture to achieve such correspondence with subglacial topography seems unlikely. For coincidence to produce such a match seems more unlikely still. Historians have proposed that Boache had access to earlier charts, now lost, that depicted Antarctic geography with greater accuracy than the explorers of his own era could achieve. These hypothetical source maps would have originated in a period when Antarctic ice was dramatically reduced, perhaps during the warm phases of the Holocene, or perhaps earlier still, during interglacial epochs when global temperatures rose and polar ice retreated. The knowledge they contained would have passed through many hands before reaching Boache, copied and recopied, its origins forgotten, its accuracy preserved through transmission even as its provenance dissolved into legend. This is speculation, of course. No such source maps have been found. No historical record documents their existence. Yet the alternative, that 3 separate map makers across 3 centuries, working with different data and different methods, all happen to depict subglacial Antarctic topography with comparable precision, strains credulity in its own way. The pattern is too consistent to ignore, even if it cannot be explained. The Boache map hangs now in academic collections, a curiosity from the age of powdered wigs and candlelit salons. Its watercolours have faded, its projections superseded by satellite imagery and computational cartography. Yet the question it raises remains fresh. How did an 18th century Frenchman sitting in Paris, drawing from incomplete reports of distant ice, produce a map that anticipated discoveries 2 centuries in the future? The ice remembers, the bedrock beneath it remembers longer, and somewhere, in the transmission of knowledge across ages and cultures, maps were made that captured what should have been invisible, charting terrain that no contemporary eye could see. The mechanism of that transmission remains obscure, the evidence of its occurrence does not. 3 maps now stand before us, each depicting lands beyond the reach of its maker's instruments, each anticipating discoveries that would not come for centuries. The Piri Reis map of Antarctic coastlines, the Zeno map of Greenland's subglacial rivers, the Boache map of Antarctica's divided landmass. Different eras, different continents, different cartographic traditions, yet the same impossible precision, the same knowledge appearing before its time, the same silence where provenance should speak. But the portfolio of anomalous maps extends further than polar regions and subglacial topography. The pattern appears wherever ancient charts are examined closely, wherever modern surveys are laid against medieval or Renaissance originals, wherever the assumption of limited ancient knowledge meets evidence that suggests otherwise. We turn now to one of the most contentious cartographic documents of the 20th century, the Vinland map. It surfaced in 1957, bound into a medieval manuscript, offered for sale to a Connecticut antiquarian book dealer. The parchment appeared old, the ink faded to brown, the Latin annotations consistent with 15th century European usage. What made the map extraordinary was not its age but its content, for it depicted, in clear outline, the coastline of North America, Vinland, the land of wine, where Viking sagas claimed Leif Erikson had made landfall 500 years before Columbus sailed. If authentic, the Vinland map would be the earliest surviving cartographic record of the New World, predating all other European depictions by decades or centuries. It would confirm in documentary form the Norse discovery of America that archaeology has since established through excavation at Lanceau Meadows in Newfoundland. It would transform our understanding of late medieval geographic knowledge, demonstrating that information about lands across the Atlantic had circulated in European scholarly circles long before the age of exploration began in earnest. Yale University acquired the map in 1965, publishing it with scholarly fanfare and immediate controversy. The authentication debate has continued for 6 decades, marshalling experts in medieval manuscripts, analytical chemistry, radiocarbon dating and spectroscopy. Opinions have swung wildly. Initial analysis suggested the ink contained anaters, a form of titanium dioxide not synthesized until the 20th century, implying modern forgery. Later studies challenged this finding, arguing that medieval inks could produce similar chemical signatures. The parchment itself has been radiocarbon dated to approximately 1434, consistent with genuine medieval origin. But parchment can be reused, old materials employed to create convincing fakes. The question of authenticity remains unresolved. Yet even if the Vinland map is genuine, even if it truly dates to the early 15th century and accurately records Norse knowledge of American coastlines, a different question emerges from its details. The map shows not only the North American coast, but Iceland and Greenland as well, and the depiction of Greenland raises familiar puzzles. The island appears as an island, entirely surrounded by water, though European navigators of the 15th century believed Greenland connected to the Asian landmass via polar regions, or extended indefinitely northward beyond the reach of exploration. No circumnavigation of Greenland occurred until 1909, when Piri and Rasmussen demonstrated conclusively that it was indeed an island, bounded on all sides by sea. How did a medieval mapmaker know? How did he or his source accurately depict Greenland's insular nature 5 centuries before exploration confirmed it? The conventional explanation invokes lucky guessing, cartographic convention, or the loss of Norse knowledge that briefly held the truth before forgetting it again. Yet the precision echoes the same patterns we have seen elsewhere. Knowledge appearing before discovery, accuracy preceding the instruments that should have been necessary. The Vinland map controversy involves more than geographic precision. It touches questions of cultural priority, national pride, and the politics of historical memory. If Viking navigators reached America, if their knowledge filtered into European cartography, then the Columbus narrative loses some of its centrality, and the history of Atlantic exploration becomes more complex, more distributed, more difficult to reduce to heroic individuals and singular moments. The map becomes a battleground not just for authentication experts, but for competing visions of the past itself. Yet beneath the controversy lies the cartographic question that binds all these documents together. The Vinland map, genuine or forged, participates in the same discourse as the Piri Reis, the Zeno, the Boace, the discourse of impossible knowledge, of precision that should not have been possible, of maps that seem to peer through ice and time to depict what contemporary observation could not reveal. If it is a forgery, it is a sophisticated one, calibrated to exploit scholarly desires and nationalistic rivalries. If it is genuine, it testifies to cartographic networks that preserved and transmitted geographic knowledge across centuries, drawing on sources whose origins remain as obscure as the frozen waters they depicted. The map rests now in the Benecke Rare Book and Manuscript Library at Yale, studied, debated, never definitively resolved. Its parchment has been sampled, its ink analysed, its every stroke measured and compared. Yet the essential mystery persists. How did its maker know what he knew? And what else did medieval cartographers know that has not survived, that crumbled in monastery fires, that sank with ships, that mouldered in attics until the knowledge it contained passed beyond recovery? The Vinland map may be genuine, it may be false. Either way, it participates in a pattern too consistent to ignore, a pattern of ancient charts that challenge modern assumptions, that suggest geographic knowledge far exceeding the instruments of their ages, that whisper of lost sources and forgotten surveys and civilizations that measured the Earth before history began to record. The controversy will continue, the arguments will circle, and the coastlines, whether real or imagined, will remain inked on parchment, inviting interpretation, resisting resolution, holding their secrets as the centuries accumulate. From the disputed parchments of medieval Europe, we turn to a map that predates them by more than a millennium, a chart crafted not on animal skin but on the plastered walls of a monastic cell, a document that combines geographic precision with spiritual vision in ways that reveal how differently the medieval mind understood the relationship between the physical world and the cosmic order. The Fra Mauro Mappa Mundi hangs in the Biblioteca Nazionale Marciana in Venice, a circular chart spanning nearly 2 meters in diameter, painted on parchment mounted on wood, completed in 1459 by a Camaldolese monk labouring in his cell on the island of San Michele in the Venetian lagoon. It is one of the finest achievements of medieval cartography, a synthesis of Arabic, Portuguese and Italian geographic knowledge, and it carries within its elaborate designs both the limitations and the unexpected sophistication of pre-modern earth science. The map orients south at the top, following the convention of Islamic cartography, rather than the north-up orientation that would become standard in later European maps. The 3 continents of the known world, Europe, Africa and Asia, crowd together in the centre, surrounded by ocean, while elaborate annotations in cramped Italian describe the features, peoples, and legends of each region. Jerusalem does not occupy the centre, as it did on many medieval TO maps. Fra Mauro placed it slightly north of centre, a geographical concession that acknowledged emerging spatial awareness. What draws modern attention to the Fra Mauro map is not its general design, but its specific details, particularly its depiction of Africa. European knowledge of the African continent in 1459 was limited. Portuguese sailors had been creeping southward along the Atlantic coast for decades, but the Cape of Good Hope would not be rounded until Bartolomeu Dias's voyage in 1488, nearly 30 years after Fra Mauro completed his chart. The interior of Africa was terra incognita, known only through rumour, legend and fragmentary reports from Arab traders who ventured inland along the caravan routes. Yet Fra Mauro's Africa displays features that seem to anticipate discoveries not made for centuries. The continent appears as a distinct landmass, entirely surrounded by water, with a southern tip that allows passage between the Atlantic and Indian Oceans. Rivers flow from central highlands in patterns that roughly correspond to the actual drainage basins of the Nile, the Congo, and the Niger. Mountain ranges rise where mountains actually stand. The Sahara spreads across the north, accurately vast, accurately barren. Lake features appear in the interior, suggestive of the Great Lakes that would not be explored by Europeans until the 19th century. How did a monk in a Venetian cell, working from second-hand reports and Arabic sources, produce a map that so closely approximated African geography? The conventional answer points to the underestimated sophistication of medieval information networks. Fra Mauro was not working in isolation. He drew on decades of accumulated reports from Portuguese expeditions, on Arab geographical texts that encoded centuries of trans-Saharan trade, on Byzantine and classical sources that preserved fragments of ancient knowledge. The precision of his map reflects not impossible foreknowledge, but careful synthesis of many imperfect sources, each contributing pieces to a puzzle that Fra Mauro assembled with remarkable skill. This explanation is plausible, perhaps even probable, yet it raises its own questions. The Arab sources Fra Mauro consulted, where did they derive their knowledge? The fragments of classical geography that filtered through Byzantine channels? What earlier surveys did they preserve? If Fra Mauro's Africa is accurate because it synthesizes accurate sources, then those sources must have originated somewhere, in surveys and expeditions and geographic investigations that the historical record has not preserved. The pattern repeats. Accuracy appears in medieval maps, and when we trace that accuracy backward, we find earlier sources, and when we trace those sources, we find still earlier origins, and eventually the trail dissolves into legend, into conjecture, into the suspicion that somewhere in deep antiquity, more systematic geographic knowledge existed than our conventional timelines allow. The suspicion lingers like morning mist over the lagoon, refusing to burn away under the light of rational inquiry. For if Fra Mauro's synthesis reveals the hidden depth of medieval information networks, it also reveals their hidden origins, threads that, when pulled, lead not forward into the age of discovery but backward, into epochs where such knowledge should not have existed at all. And so we turn now from the monk's cell in Venice to a far older document, one that predates Fra Mauro by more than 3,000 years, one that emerges from the sand-scoured tombs of ancient Egypt with a specificity that challenges everything we assume about the cartographic capabilities of the ancient world. The Turin Papyrus lies today in the Museo Egizio in Turin, Italy, fragmented and faded, its pieces arranged under glass like the scattered bones of some prehistoric creature awaiting reconstruction. When complete, the papyrus measured approximately 2.8 meters in length and 0.41 meters in height, making it one of the largest surviving papyri from ancient Egypt. It dates to the reign of Ramesses IV, approximately 1150 BCE, and it depicts the Wadi Hammamat, a dry riverbed cutting through the eastern desert between the Nile Valley and the Red Sea coast. The region was crucial to ancient Egyptian industry, for it contained quarries of Bekan stone, a dark, prized grey wacke used for statues and sarcophagi, as well as gold mines that fed the treasuries of the pharaohs. The papyrus was prepared for an expedition to these quarries, a working document meant to guide administrators and labourers through the desert landscape to their industrial destinations. What makes the Turin Papyrus remarkable is not merely its age, but its nature. This is not a symbolic representation of territory, not a cosmological diagram, not a pictorial narrative of royal conquest. This is a geological map, perhaps the oldest surviving geological map in human history. The papyrus depicts the Wadi with attention to topographic features, marking the locations of gold deposits and Bekan stone quarries, indicating the distribution of different rock types through colour coding. Hills appear in brown and pink to indicate ignite and granite. The Bekan stone deposits are shown in their proper positions relative to the Wadi channel. Routes and distances are annotated in hieratic script. The map is oriented with the source of the Wadi at the top, following the convention of Egyptian cartography that placed south, the direction of the Nile's origin, at the top of representations. Modern geological surveys of the Wadi Hammamat confirm the essential accuracy of the Turin Papyrus. The quarries lie where the papyrus indicates. The distribution of rock types corresponds to the colour-coded regions on the ancient document. The relative positions of geographic features, the hills, the Wadi channel, the locations of mineral deposits, match the terrain as it exists today, 3,000 years after the papyrus was drawn. Geologists and archaeologists who have compared the ancient map to modern surveys express consistent surprise at the sophistication of the representation. This is not a crude sketch, but a functional geological document, one that could guide a modern expedition to the same deposits that Ramesses IV sought to exploit. The conventional explanation for the Turin Papyrus emphasises the practical necessities of Egyptian administration. The pharaonic state was a vast bureaucratic apparatus that organised labour, extracted resources, and recorded information with obsessive thoroughness. The Egyptians were experienced miners. They had been exploiting the gold and stone of the eastern desert for centuries before Ramesses IV dispatched his expedition. The Turin Papyrus represents the culmination of that experience, a synthesis of accumulated knowledge recorded by scribes who understood the terrain through generations of industrial activity. The map is accurate because it was made by people who had walked the Wadi, worked the quarries, and extracted the gold. People for whom precision was not academic but essential. This explanation satisfies to a point, yet it does not fully account for the conceptual leap the papyrus represents. A geological map is not merely a record of where things are. It is a representation of the Earth's structure, a translation of three-dimensional terrain into two-dimensional abstraction, a cognitive achievement that requires both empirical observation and systematic methodology. The colour coding of rock types implies a classificatory system, a geological vocabulary that distinguished between different kinds of stone based on their properties and locations. The accurate rendering of topographic relationships implies surveying techniques capable of measuring distances and angles with sufficient precision to produce a functional representation. The orientation and annotation imply a cartographic tradition, conventions of representation that the map's creators shared with its intended users. Where did this tradition originate? The Turin Papyrus is the oldest surviving geological map, but it cannot be the first such map ever made. The sophistication of its execution suggests a mature practice, one that developed over time through trial and refinement. Earlier geological maps must have existed, simpler versions that evolved toward the complexity displayed in the Ramesses IV document. Yet no earlier examples survive. The papyrus emerges from the archaeological record as if fully formed, a product of a cartographic tradition whose developmental stages remain invisible to modern investigation. The same pattern appears here as elsewhere. Knowledge surfaces in the ancient record with an unexpected completeness, and when we seek its origins we find only absence, only the suggestion that more must have existed than the fragmentary evidence reveals. The Egyptians who made the Turin Papyrus knew their territory with a precision that seems to exceed the capabilities we typically attribute to Bronze Age societies. They could measure, classify, represent and communicate geographic information in ways that would not become standard in European cartography until the Renaissance. How did they achieve this? What earlier surveys informed their work? What accumulated wisdom, lost when the old kingdoms fell, when the libraries burned, when the scribal traditions were interrupted, lies behind the competence so casually displayed on a working document for a mining expedition? The questions multiply and the answers recede. Standing before the fragments in Turin, one cannot help but sense the weight of vanished knowledge, the suspicion that this papyrus is a window into capabilities far more extensive than the surviving evidence documents. The Egyptians mapped their world with skill and purpose, and the few remnants that chance has preserved hint at a cartographic tradition whose full scope we can only imagine. From the sands of Egypt, we turn now to the alluvial plains of Mesopotamia, to a small clay tablet that offers a very different kind of geographic representation, one that reveals not the practical precision of working surveyors, but the cosmological imagination of an ancient civilization grappling with its place in the universe. The Babylonian world map resides today in the British Museum, a modest clay tablet measuring approximately 12 centimetres by 8 centimetres, its surface incised with cuneiform text and a circular diagram that represents the Earth as the Babylonians conceived it. The tablet dates to approximately the 6th century BCE, though it may be a copy of an earlier original, and it was discovered in the 19th century at Sippar, an ancient city on the Euphrates some 60 kilometres south of modern Baghdad. The tablet is fragmentary. Portions have broken away, and the cuneiform text is partially illegible. Yet enough survives to reveal the essential structure of the Babylonian geographic imagination. At the centre of the diagram lies Babylon itself, marked by a rectangle representing the city. The Euphrates River flows through the centre, depicted as two parallel lines running from the northern mountains to the southern marshes. Around the central landmass, 7 or 8 cities are marked: Assyria, Urartu, and others whose identifications remain debated, arranged in a rough circle. Surrounding this inhabited world, a circular band represents the Maratu, the salt sea or ocean that the Babylonians believed encircled the earth. Beyond the ocean, triangular projections extend outward like rays from a sun, labelled as Nagu, regions or islands accessible only by crossing the cosmic sea. These outer regions are described in the cuneiform text as places of darkness, cold, and strange creatures, realms beyond normal human experience. The conventional interpretation of the Babylonian world map emphasises its cosmological rather than practical function. This is not a map meant for navigation or administration. It is a diagram of the world as understood through Babylonian mythology and scholarship, a representation of cosmic order rather than geographic reality. The proportions are schematic rather than accurate. Babylon occupies the centre because Babylon was the centre of the Babylonian universe, not because it lay at the geographic midpoint of the known world. The outer regions are symbolic, representing the unknown and the fearsome, rather than actual territories that might be visited. The map is a theological document as much as a geographic one, expressing the Babylonian understanding of their place in creation. Yet within this cosmological framework, certain details resist purely symbolic interpretation. The positioning of cities and regions, while schematic, reflects genuine geographic relationships. Assyria lies to the north of Babylon, as it did in reality. The Euphrates flows in the correct direction. The mountains appear where mountains should appear. The marshes occupy the south. where marshes actually dominated the lower Euphrates Valley. The Babylonian world map is not accurate in the sense that the Turin Papyrus is accurate, but neither is it purely fantastical. It encodes real geographic knowledge within a cosmological shell, preserving observations about the world even as it interprets those observations through mythological categories. More intriguing still are the outer regions, the Nagu beyond the cosmic ocean. The cuneiform text describes these regions in terms that have invited centuries of speculation. One triangular projection is described as a place where the sun is not seen, a land of perpetual darkness. Another is called a place of cold and ice. The descriptions are fragmentary and debated, but they suggest an awareness, however mythologized, of conditions very different from those in Mesopotamia. A land without sun, a land of ice. Were the Babylonians describing rumours of the Arctic, transmitted through chains of trade and communication that stretched far beyond their immediate knowledge? Were they preserving echoes of earlier geographic lore, perhaps originating in traditions that predated Babylon itself? The questions cannot be definitively answered, but they cannot be dismissed either. The Babylonian world map presents itself as cosmological abstraction, yet embedded within that abstraction are traces of geographic awareness that seem to exceed what the Babylonians could have observed directly. The same pattern recurs. Knowledge appears in ancient documents, knowledge that seems to exceed the apparent capabilities of its creators, and when we seek the origins of that knowledge, we find only the silence of vanished sources, lost libraries, erased traditions. The Babylonians, like the Egyptians, mapped their world with the tools available to them, and the maps they created encode both their understanding and their mysteries. The clay tablet in the British Museum is small enough to hold in one hand, yet it carries the weight of cosmic imagination, and perhaps, just perhaps, the faint traces of geographic knowledge whose origins lie beyond the reach of conventional history. From the clay tablets of Mesopotamia, we journey now across thousands of miles and thousands of years to the open waters of the Pacific, to a form of cartography so utterly different from anything we have yet considered that it challenges our very definition of what a map can be. Here, among the islands scattered like jewels across the vast blue emptiness of the ocean, the Polynesian peoples developed navigational techniques that enabled them to cross thousands of miles of open water without compass, sextant, or written chart. And among the tools they created, one stands as a testament to a form of geographic intelligence that Western cartography has only recently begun to understand. The stick charts of Micronesia and the Marshall Islands are navigational devices made from the midribs of coconut palm fronds, tied together with coconut fibre to form geometric patterns that represent the ocean and the islands it contains. Unlike Western maps, which depict coastlines and landforms, the stick charts encode the patterns of ocean swells, the long rolling waves that travel across the Pacific, bending and reflecting around islands in predictable ways. A skilled navigator, trained from childhood to read these subtle variations in wave pattern, could detect the presence of an island long before it became visible, could sense land from dozens of miles away through the motion of the canoe beneath his body. The stick charts come in several types. The matang is a teaching device, an abstracted representation of wave refraction patterns used to train young navigators in the principles of swell reading. The meadow depicts a section of the island chain, showing the positions of specific islands relative to each other and the swell patterns between them. The reblib represents the entire Marshall Islands chain, a comprehensive overview of the archipelago and its wave geography. Each chart was made for a specific navigator and kept secret. The knowledge encoded was proprietary, passed from master to apprentice within navigational lineages. What makes the stick charts extraordinary is not merely their ingenuity but their accuracy. Modern oceanographic studies of Pacific wave patterns confirm that the swell dynamics represented in the stick charts correspond to actual physical phenomena. Islands do bend and reflect swells in predictable ways. The patterns encoded in the charts can be detected and measured with modern instruments. The Polynesian navigators, working without written mathematics, without instruments, without any of the tools that Western science considers necessary for precise observation, nevertheless developed an accurate understanding of complex hydrodynamic phenomena and encoded that understanding in a form that could be taught and transmitted across generations. The conventional explanation for the stick charts emphasizes the adaptive ingenuity of Polynesian culture. Isolated on small islands in the vast Pacific, the Polynesians faced navigational challenges unmatched anywhere else on Earth. Survival demanded the ability to voyage between islands, to maintain trade networks, to colonize new territories. Under this selection pressure, they developed navigational techniques of extraordinary sophistication, techniques honed over centuries of trial and error, passed from generation to generation through rigorous apprenticeship. The stick charts are the product of accumulated wisdom, the crystallization of millennia of empirical observation, encoded in a form suited to the materials and cultural practices of their creators. This explanation is compelling, and it is almost certainly correct in its essentials. Yet it too raises questions. The Polynesian settlement of the Pacific was one of the most remarkable achievements in human history, a colonization of ocean space that dwarfs any comparable expansion by land-based peoples. Over a period of roughly 2,000 years, Polynesian voyagers spread from Southeast Asia across the entire Pacific, reaching Hawaii to the north, Easter Island to the east, New Zealand to the southwest, and hundreds of islands in between. This expansion covered distances of thousands of miles, across open ocean where no landmarks existed, where a navigation error of even a few degrees could mean death. How did they accomplish it? The conventional timeline suggests that Polynesian voyaging techniques developed gradually, reaching their peak during the period of active expansion, and then declining in some regions as populations stabilized on their islands. Yet the stick charts themselves are difficult to date. The ones that survive in museum collections are mostly from the 19th and early 20th centuries, created for anthropologists who sought to document vanishing traditions. The earlier history of the charts is obscure. Were they used during the great voyages of expansion, or did they develop later as navigational aids for shorter inter-island journeys? Did the master navigators who crossed thousands of miles to Hawaii and Easter Island use stick charts, or did they rely on other techniques, star paths, bird sightings, cloud formations, that left no physical trace? The questions lead us back once again to the familiar territory of lost knowledge. The Polynesian navigators possessed capabilities that modern science has only recently begun to appreciate, and the tools they created encode an understanding of ocean dynamics that required centuries of observation to develop. The stick charts that survive are fragments of a larger tradition, remnants of a body of navigational lore that was once far more extensive. What has been lost, we cannot know. What the great voyagers knew, as they set out across the empty Pacific toward islands they had never seen, relying on subtle cues invisible to untrained senses. This knowledge is largely gone, preserved only in the imperfect records of anthropologists and the few surviving practitioners who still remember the old ways. The stick charts stand as a reminder that cartography takes many forms, that the mapping of space is not limited to lines on paper or figures on screens. The Polynesians mapped the ocean in 3 dimensions, not merely the horizontal spread of islands, but the vertical and temporal dynamics of waves, the interplay of swell and refraction that created a readable landscape on the featureless sea. This was geographic intelligence of a profound and alien kind, a way of knowing the world that Western science is still struggling to comprehend. And so, from the frigid Antarctic of the Piri Reis map to the subglacial Greenland of the Zeno brothers, from the ice-free continent of Philippe Boichet to the controversial parchment of the Vinland map, from Fromauro's African synthesis to the Egyptian geological precision of the Turin Papyrus, from the cosmological imagination of the Babylonian world map to the hydrodynamic genius of the Polynesian stick charts, a pattern emerges, insistent and irreducible. In each case, a map appears that contains knowledge exceeding what its creators should have possessed. In each case, the conventional explanation points to synthesis, to accumulated observation, to the underestimated sophistication of pre-modern peoples. And in each case, that explanation, however valid, opens new questions. Where did the synthesized knowledge originate? How far back does the chain of transmission extend? What surveys, what voyages, what forgotten investigations produced the raw data that later cartographers assembled? The maps themselves offer no definitive answers. They sit in their museum cases under glass, preserved against the decay that has claimed so much else, and they wait. They wait for interpreters with new questions, for technologies not yet invented, for discoveries not yet made. The land remembers, the stones whisper, the ocean holds its secrets in the endless rhythm of its swells, and the ancient maps, scattered across the globe, point toward mysteries that refuse simple resolution. What vanished civilization, what forgotten network of observers might have accumulated the geographic knowledge that surfaces again and again in these impossible documents? Were there surveys in deep antiquity that we have no record of, expeditions that crossed the world and measured it with precision, only to see their findings scattered and fragmentary copies preserved by chance in the archives of later peoples? Or is the explanation simpler, the maps reflecting only the gradual accumulation of observation by cultures we have underestimated, whose achievements we are only now beginning to appreciate? The questions hang in the air, unanswered, perhaps unanswerable. The maps remain, their details precise, their implications vast, their origins shrouded in the silence of time. One cannot help but feel, studying them, that the Earth has been known before, known and mapped and measured, in ages that left no written record, by peoples whose names have been forgotten, whose works survive only in these scattered fragments, these impossible charts that seem to whisper of a world before the world we know. And perhaps that whisper is loudest not in the grand continental outlines or the navigational genius of ocean wayfinders, but in something far more humble, far more easily overlooked, the simple act of drawing a river. For cartography, at its most fundamental, is the recording of what lies beneath one's feet, the terrain one walks, the water one drinks, the mountains that block the path and the valleys that offer passage. Before the great age of exploration, before ships crossed oceans and surveyors triangulated continents, there were maps of the local, the immediate, the landscape of daily life. And among these, one document stands apart, not for its scope, but for its precision, not for what it imagines, but for what it observes. A papyrus scroll that has survived 3,000 years, depicting a landscape that geologists can still walk today. The Turin Papyrus, housed in the Egyptian museum of that Italian city, is the oldest known geological map in existence. Dating to approximately 1150 BCE, during the reign of Ramesses IV of the 20th dynasty, it was created not for grand imperial purposes, but for a specific practical task: the extraction of Bechen stone, a prized greenish-grey stone used for statues and sarcophagi, from the quarries of Wadi Hammamat in Egypt's eastern desert. The map depicts a 15-kilometre stretch of this wadi, a dry riverbed that channels flash floods through the mountainous terrain between the Nile Valley and the Red Sea coast, and it does so with a precision that has astonished modern researchers. The Bechen stone quarry is marked, as are deposits of gold-bearing quartz, the locations of workers' huts, the routes of roads, and most remarkably the geological character of the terrain itself. Different rock types are distinguished by different colours: the pink granite of the mountains, the black basalt of a volcanic intrusion, the greyish-green of the sedimentary Bechen stone. This is not merely a map, it is a geological survey, a document that records not just where things are but what they are made of, rendered in a visual language that a modern geologist can read with startling ease. The conventional explanation for the Turin Papyrus is straightforward enough. It was created by Amenakte, a scribe associated with the community of Deir el-Medina, the village that housed the workers who built and decorated the royal tombs in the Valley of the Kings. Amenakte, or someone in his circle, accompanied an expedition to Wadi Hammamat, either to oversee the extraction of stone or to plan such an extraction, and produced this map as a practical guide for the work ahead. The precision of the map reflects the practical needs of quarrying. Knowing where the valuable stone lies, where gold might be found, where water can be obtained in the arid landscape, where shelter exists for the workers. The geological colour coding, while impressive, simply records what any observant person could see in the wadi itself: the different colours of the rock faces, the distinct textures and compositions visible to the naked eye. There is nothing mysterious here, merely the product of careful observation by skilled scribes serving the needs of the Egyptian state. Yet certain aspects of the Turin Papyrus continue to invite deeper reflection. The map is drawn to scale, not approximately, not symbolically, but with a consistent relationship between distance on the papyrus and distance on the ground that modern surveyors have verified. The 15 kilometres of wadi depicted on the scroll can be walked today, and the features marked on the 3,000-year-old document correspond to features still visible in the landscape: the shape of the hills, the bends in the dry riverbed, the locations of the quarries whose ancient tool marks remain visible on the rock faces, This is not the symbolic cartography of religious imagination or the schematic representation of administrative convenience. This is measured, proportional, geographically accurate mapping of a specific terrain, executed with techniques that the Western world would not redevelop until the Renaissance, and in some respects not until the systematic geological surveys of the 19th century. How did the Egyptians achieve this precision? The question is not trivial. Accurate scaled mapping requires consistent measurement of distance across rugged terrain, the ability to maintain directional accuracy over extended distances, and a conceptual framework that translates three-dimensional landscape into two-dimensional representation with consistent proportionality. The Egyptians certainly possessed sophisticated surveying techniques. The precision of the pyramids attests to that, but those techniques were applied to controlled construction sites, not to wild wadis stretching through desert mountains. The rope stretchers who laid out the foundations of temples worked on prepared ground using established baselines and careful procedures refined over generations. The terrain of Wadi Hammamat offers no such conveniences. It is rugged, complex, folded by geological forces into shapes that resist easy measurement, and yet the map is accurate. Modern comparisons have confirmed it. The proportions hold, the distances match, the geology corresponds. Perhaps the explanation is simply that we have underestimated Egyptian capabilities, that the same civilization that built monuments we still struggle to comprehend also possessed survey techniques we have not credited them with. This is plausible, even likely. The evidence of Egyptian precision in architecture, in astronomy, in hydraulic engineering suggests a level of technical sophistication that conventional history has been slow to appreciate. The Turin Papyrus may simply be one more data point in a larger pattern, another instance where the achievements of the ancients exceeded our assumptions. But this explanation, while satisfying, opens further questions. If the Egyptians could produce such maps in the reign of Ramesses IV, what maps did they produce earlier? The Turin Papyrus is the oldest surviving geological map, but it is clearly not the product of a tradition just beginning. It shows the confidence and sophistication of a mature practice, techniques refined over time, conventions established and followed. Where are the earlier examples? What maps guided the quarrying expeditions of the Old Kingdom, the extraction of granite from Aswan for the pyramids, the sourcing of copper from Sinai and gold from Nubia? These maps, if they existed, have not survived. Papyrus decays in all but the driest conditions, and even Egypt's climate has not preserved everything. The Turin Papyrus itself survived only by chance, found fragmented in a tomb and reassembled by modern scholars. How much else has been lost? And then there is the question of transmission. The Egyptians were in contact with other civilizations throughout their long history, with Mesopotamia, with the Mediterranean world, with the peoples of the Levant and the Red Sea coast. Did their surveying techniques spread beyond their borders? Did other cultures learn from Egyptian methods, adapting them to their own needs, passing them along chains of contact that we can no longer trace? The Turin Papyrus depicts a local landscape, a specific wadi in a specific desert, but the techniques it embodies may have had a far wider reach. When we encounter precision in ancient maps from other cultures, the Babylonian awareness of distant lands, the medieval Islamic cartographers who built on Greek and Indian and Chinese traditions, are we seeing independent developments or echoes of a shared heritage, a global network of geographic knowledge that accumulated over millennia and surfaced in different forms in different places? The map itself cannot answer these questions. It lies in its museum case, its colours faded but still visible, its contours still legible to those who know how to read them. Geologists have walked the terrain it depicts and confirmed its accuracy. Art historians have analysed its style and placed it within the context of New Kingdom visual culture. Papyrologists have dated its material and studied the handwriting of its scribes. The conventional interpretation accounts for what we see, a practical document created for a specific purpose, reflecting the observational skills and technical capabilities of its makers, and yet the precision remains, precise beyond easy explanation, accurate in ways that seem to anticipate methods developed centuries or millennia later. The Beacon stone quarries still lie where the map marks them. The gold-bearing quartz still glitters in the rock faces. The wadi still cuts its way through mountains whose colours, pink and black and greyish-green, still match the pigments the ancient scribe applied to papyrus 31 centuries ago. From the specialised precision of the Turin Papyrus, our attention turns now to a document of radically different character. A map not of a single wadi, but of the entire world. Not of geology, but of cosmology. Not a practical guide for workers, but a statement of how a civilization understood its place in the universe. The Babylonian world map, also known as the Imago Mundi, is a small clay tablet measuring only 12 centimetres by 8, held now in the British Museum and dating to approximately 600 BCE during the Neo-Babylonian period. It is, by conventional standards, a crude and schematic representation. A circular world surrounded by water, with Babylon at its centre and a handful of labelled regions radiating outward. Compared to the precision of the Turin Papyrus or the continental scope of the Piri Reis map, it seems almost primitive, a child's drawing of a universe imagined rather than observed. And yet this small clay tablet raises questions as profound as any of the more sophisticated documents we have examined. Questions about what the ancient Mesopotamians knew of the world beyond their borders and how that knowledge found its way into their cosmological imagination. The map depicts the world as a flat disk, surrounded by a circular ocean labelled Maratu, the Bitter River or Salt Sea. At the centre lies Babylon, marked with a rectangle representing the city. The Euphrates River flows through the disk from north to south, connecting the mountainous regions of the north to the marshlands of the south. Around Babylon, a handful of other regions are labelled Assyria, Urartu, and several others whose names are damaged or unclear. Beyond the encircling ocean, triangular regions project outward like rays from a sun labelled Nagu, a term usually translated as regions or districts. These outer triangles represent lands beyond the known world, places at the edges of existence where strange beings dwell and the normal rules of geography no longer apply. The cuneiform text accompanying the map describes these regions in mythological terms. One is a place where the sun is not seen, another where winged birds cannot fly, another where a great hero once travelled in ancient times. The conventional interpretation of the Babylonian world map emphasises its cosmological and mythological character. This is not a practical navigation tool or a record of geographic observation. It is a theological document, a representation of how the Babylonians understood the structure of the cosmos. Babylon lies at the centre because Babylon is the centre of Babylonian civilization, the axis around which their world turns. The encircling ocean reflects Mesopotamian creation mythology, in which the primordial waters were divided to form the world. The outer triangles represent the unknown, the realm of myth and legend, places that exist more in story than in geography. The map, in this reading, tells us almost nothing about Babylonian geographic knowledge and almost everything about Babylonian worldview. Their sense of cosmic order, their placement of themselves at the centre of creation, their understanding of the boundaries between the known and the unknown, the real and the mythological. Yet certain details of the Babylonian world map continue to provoke scholarly attention. The labelled regions around Babylon correspond, in some cases, to real places that the Babylonians knew through trade and diplomacy and war. Assyria is real. Urartu in the mountains of eastern Anatolia is real. The marshlands to the south are real. The Euphrates flows where the Euphrates flows. Even in its schematic simplicity, the map reflects genuine geographic knowledge embedded within a cosmological framework. And the outer triangles, those mysterious Nagu beyond the encircling ocean, what did the Babylonians imagine lay there? The texts describe them in mythological terms, but mythology often encodes real geographic information, distorted by distance and time and the limitations of communication. Were the Babylonians aware, however dimly, of lands beyond their known world, lands across the Mediterranean perhaps, or around the coasts of Africa, or in the distant east? Did traders' tales and travellers' reports filter into their cosmological imagination, transformed into the language of myth but preserving some kernel of genuine geographic knowledge? We cannot know for certain. The Babylonian world map is a single artefact, one interpretation among many that might have existed in ancient Mesopotamia. Other maps may have been more practical, more detailed, more geographically accurate, but clay tablets survive only when preserved by specific conditions, and much has been lost. What we can say is that the map reflects a sophisticated conceptual framework, a way of organising geographic and cosmological knowledge into a coherent visual representation. The Babylonians were not naive. They knew their map was schematic, knew that the world was more complex than a simple disk with 8 triangular appendages. But they chose to represent it this way, for purposes we can only partially reconstruct. The map served functions we may not fully understand: religious, political, educational, perhaps magical. And within its simplified contours, traces of real geographic knowledge persist, reminders that even the most symbolic representations often have roots in observation, in the accumulated experience of travellers and traders who ventured beyond the familiar and returned with stories of what lay beyond. The contrast between the Turin Papyrus and the Babylonian world map illuminates something fundamental about the nature of cartography. Maps are never neutral records of space. They are always interpretations, shaped by the purposes of their makers, the limitations of their knowledge, the conceptual frameworks through which they understand the world. The Egyptian scribe who created the Turin Papyrus sought practical accuracy, the precise location of resources in a specific landscape. His map is detailed, proportional, geologically attentive, because his purpose demanded it. The Babylonian cosmographer who created the Imago Mundi sought something else: a representation of cosmic order, a visual theology, a diagram of existence with Babylon at its sacred centre. His map is schematic, symbolic, mythologically rich, because his purpose demanded that instead. Neither is more true than the other. Both encode genuine knowledge within their chosen frameworks, and both raise the same fundamental question: how did their makers know what they knew? For the Turin Papyrus, the answer seems clear enough: direct observation, careful measurement, the accumulated expertise of a quarrying tradition stretching back centuries. But even this clarity dissolves on closer examination. The techniques of measurement, the methods of surveying, the conventions of representation, where did these originate? How far back does the chain extend? The papyrus is a product of tradition, and traditions have origins, developments, forgotten ancestors. For the Babylonian world map, the question is even more open. The schematic representation obscures as much as it reveals, and the mythological language in which the outer regions are described makes it impossible to determine how much genuine geographic knowledge underlies the cosmological imagination. Did the Babylonians have sources we know nothing of, travellers' accounts or traders' reports, or diplomatic communications that inform their sense of the world's extent? Did they inherit traditions from earlier Mesopotamian civilizations, from the Sumerians or the Akkadians, who in turn might have received information from yet earlier peoples? These questions find no easy answers in the documents themselves. The maps offer their details, their precisions and their ambiguities, and then fall silent. We are left to interpret, to speculate, to construct narratives that connect what we can see to what we might imagine. And always, beneath the surface of even the most conventional explanation, the mystery persists, the sense that these ancient peoples knew more than we have credited them with, that the maps preserve fragments of knowledge whose origins we cannot trace, that the earth has been known and measured and represented in ways that our histories do not record. The Turin Papyrus waits in its museum case, its colours still marking the geology of a wadi that still exists, still accurate after 3 millennia. The Babylonian world map waits in its own case, its clay surface bearing the cuneiform characters that describe a cosmos centred on a city that fell to the Persians 25 centuries ago, a cosmos with regions beyond the ocean where heroes travelled and the sun did not shine. Both maps whisper of what their makers knew, and of what we have forgotten they knew, and of the endless complexity of the human effort to understand and represent the world. The pattern that emerges from this survey, from Antarctic coastlines to Greenland fjords, from pre-glacial continents to controversial parchments, from Italian masterworks to Egyptian quarry maps, to Mesopotamian cosmologies to Polynesian wave charts, is not one of simple mystery or straightforward explanation. It is a pattern of layered knowledge, of traditions built on traditions, of information accumulated and transmitted and sometimes lost, surfacing in unexpected forms in documents scattered across millennia and continents. The conventional explanations account for much. The Piri Reis map synthesized earlier sources, the Zeno brothers compiled genuine observations, Philippe Boitier extrapolated from incomplete data, Fra Mauro consulted travellers, the Turin Papyrus reflected Egyptian surveying skill, The Babylonian map encoded cosmological imagination. The Polynesian charts preserved navigational expertise. These explanations are not wrong. They are in most cases probably substantially correct. But they do not close the inquiry, they open it. They push the questions backward in time, to the sources behind the sources, the surveys behind the surveys, the knowledge that made the knowledge possible. And so the mystery persists, not as a rejection of conventional history but as an extension of it, a recognition that the human past is deeper and more complex than our records preserve. The maps that survive, the handful of documents that have escaped the decay of papyrus and the crumbling of clay and the burning of libraries, are windows into that complexity, fragmentary glimpses of traditions that were once far more extensive. What has been lost, we cannot fully know. What earlier civilizations understood about the shape of the world, how that understanding was accumulated and transmitted, where the chains of knowledge originated, these remain open questions, resistant to definitive resolution, inviting continued investigation. The ancient cartographers left their marks on stone and clay and papyrus and parchment, and those marks speak across the centuries, describing a world that in some ways we still struggle to comprehend, recording observations whose accuracy we're only now equipped to verify, preserving knowledge whose origins remain shrouded in the silence of deep time. And perhaps nowhere is that silence more eloquent, more charged with the weight of accumulated tradition and navigational genius, than in the waters of the Pacific, where for centuries before European contact, Polynesian voyagers crossed thousands of miles of open ocean, using instruments so deceptively simple that early Western observers dismissed them as primitive curiosities, failing entirely to recognize the profound sophistication encoded in their apparently crude forms. The stick charts of the Marshall Islands, Rebolib, Matang and Meadow represent a cartographic tradition unlike any other in human history, a method of encoding oceanic knowledge that operates on principles so different from Western map-making that the two systems seem almost to belong to different epistemological universes. And yet, when modern oceanographers and physicists have analysed what these charts represent, they have discovered that the Marshallese navigators understood phenomena that Western science would not formalise until the 20th century, that their stick-and-shell constructions encode wave refraction patterns, swell dynamics, and island interference signatures with an accuracy that challenges explanation. The stick charts are constructed from palm ribs or the midribs of coconut fronds, lashed together with coconut fibre to form geometric frameworks. Small cowrie shells are attached at specific points, marking the locations of islands. At first glance, the resulting object appears abstract, almost artistic, a geometric pattern that bears no obvious resemblance to a conventional map. The angles seem arbitrary. The distances between shells do not correlate to geographic distances, and the overall shape offers no recognisable outline of any landmass. Early European collectors acquired these objects as ethnographic curiosities, categorising them alongside other examples of primitive navigation aids without understanding what they actually represented. The conventional museum label might describe them as crude mnemonic devices, teaching tools for apprentice navigators or stylised representations of island groups. Such explanations are not entirely incorrect. The charts were indeed used for instruction, passed from master navigators to their students, as part of an oral tradition of seafaring knowledge. They did serve as memory aids, encoding information that navigators would internalise and carry with them on voyages. But these functional descriptions barely scratch the surface of what the charts actually accomplish, of the depth of physical understanding they encode, of the precision with which they represent phenomena invisible to the untrained eye. What the stick charts primarily represent is not the islands themselves, but the patterns of ocean swells as they interact with those islands. The charts encode what happens to waves when they encounter land, how swells refract around island masses, how they reflect back from shorelines, how different wave trains intersect and interfere to create distinctive patterns that a trained navigator can read like a road map. The angles of the sticks represent the angles at which refracted waves approach a vessel, the zones of intersection where different swell systems meet. The shells mark not just island locations but nodes in the wave interference pattern, points where distinctive wave signatures indicate proximity to land even when the land itself remains invisible below the horizon. This is not metaphor. This is not mystical intuition dressed in scientific language. This is hydrodynamics, encoded in palm fibre and shell, understood empirically by Marshallese navigators centuries before the mathematical formalization of wave theory. Modern oceanographic research has confirmed the physical reality of the phenomena the charts describe. When ocean swells encounter an island, they do not simply stop at the shoreline. They bend around the island, refracting in predictable patterns that extend for many miles into the surrounding sea. They also reflect, bouncing back from the shore to create interference patterns with incoming waves. The intersection of refracted and reflected waves creates zones of distinctive wave behaviour, areas where the sea surface becomes choppy in characteristic ways, where the rhythm of the swells shifts subtly but detectably, where a navigator attuned to these patterns can sense the presence of land far before it becomes visible. These wave shadows and reflection patterns can extend 20, 30, even 50 miles from an island, creating navigational signatures that persist in conditions when stars are obscured by clouds and when celestial navigation becomes impossible. The Marshallese navigators learned to feel these patterns through the motion of their canoes, to read the subtle shifts in wave rhythm through their bodies, to know where they were in the vast Pacific by the texture of the ocean beneath them. The precision required to develop such knowledge is staggering. The wave patterns around each island are unique, shaped by the island's size, orientation and position relative to the prevailing swells. To map these patterns, navigators had to observe countless voyages, accumulate observations across generations, test their knowledge against the unforgiving reality of open ocean navigation, where error meant death. The stick charts represent the crystallization of this multi-generational research, the distillation of empirical hydrodynamics into a transmissible form, and the charts worked. Marshallese navigators routinely crossed hundreds of miles of open ocean, finding low-lying atolls that rise barely 10 feet above the sea surface, hitting their targets with a reliability that European sailors with compasses and sextants and chronometers would have envied. The charts encoded genuine physical knowledge in a format so different from Western convention that their sophistication was invisible to observers expecting latitude lines and coastal outlines. Yet even granting the remarkable nature of this achievement, conventional explanation accounts for much. The Marshallese had centuries to develop their system, generations of navigators whose lives depended on accurate understanding of the ocean. Natural selection, in the most literal sense, would favour those who understood wave dynamics. Those who could read the pattern survived to teach the next generation, while those who could not simply disappeared into the vastness of the Pacific. The knowledge accumulated incrementally, each generation adding observations to the collective understanding, refining the charts, extending the network of islands whose wave signatures were mapped. There is no need to invoke lost civilizations or forgotten technologies to explain the stick charts. They represent the achievement of Polynesian culture itself, the product of a maritime society whose entire existence depended on mastering the ocean. But even this adequate explanation opens deeper questions rather than closing them. How far back does the knowledge extend? The Marshallese stick charts are the most famous examples, but similar navigation techniques appear throughout Polynesia, suggesting a common origin somewhere in the distant past. The settlement of the Pacific, one of humanity's greatest feats of exploration and colonization, began thousands of years ago, with seafarers pushing eastward from Southeast Asia into Melanesia, then further east into the remote Pacific, eventually reaching Hawaii to the north, Easter Island to the east, and New Zealand to the southwest. This Polynesian diaspora covered more than 15 million square miles of ocean, accomplished by sailors in double-hulled canoes without any of the instruments that Western navigators considered essential. The star navigation techniques they used are well documented. The rising and setting points of stars, the star compass, the zenith stars that passed directly over specific islands. But what of the wave reading? How early did this sophisticated understanding of hydrodynamics develop? Were the original settlers of the Pacific, the first humans to cross thousands of miles of open ocean, already equipped with this knowledge, or did it develop later after the islands were found by other means? The archaeological record offers no direct answers. Navigation knowledge, like all oral tradition, leaves no physical trace until it is embodied in objects like the stick charts, and the charts themselves are fragile, unlikely to survive for long in the tropical climate. The ones that exist in museum collections date from the 19th and early 20th centuries, made for ethnographic collectors, or as replicas of instruments that were by then falling out of use. The tradition behind them is far older. The techniques described in oral histories stretch back beyond reliable genealogical memory, but how much older, we cannot say. The first European contact with Polynesian navigation came with the voyages of Cook and his contemporaries in the 18th century, by which point the tradition was already ancient, already mature, already capable of feats that European observers found nearly unbelievable. The stick charts, encountered by Europeans only in the Marshall Islands, might be a local innovation, a particular encoding of knowledge shared more broadly across Polynesia, or they might preserve a specific tradition with its own deep history, divergent from other Polynesian navigation systems, representing one branch of an ancient and varied knowledge tree. And here the questions multiply. If wave-reading navigation developed in the Pacific independently of other maritime traditions, it speaks to the universal potential of human observation, the capacity of any sufficiently motivated culture to develop sophisticated understanding of natural phenomena through empirical attention. But if it represents a preservation of earlier knowledge, carried into the Pacific by the original settlers, then where did that knowledge originate? The ancestors of the Polynesians came from Southeast Asia, ultimately from Taiwan according to the leading archaeological and genetic models, spreading across Indonesia and Melanesia, before pushing out into the deeper Pacific. Did they bring proto-navigation knowledge with them, techniques that would later crystallize into the stick chart system and the stellar navigation of the Pacific navigators? Did coastal peoples of prehistoric Southeast Asia understand wave dynamics in ways that left no archaeological trace but persisted in the practices of their descendants? These questions cannot currently be answered. The evidence is simply not there, or rather, it exists only in the form of the knowledge itself, surviving in the practices and traditions that proved their worth by enabling their practitioners to survive. What strikes the careful observer is the difference between this navigation tradition and everything else we have surveyed. The Piri Reis map, the Zeno map, the Boache map, these are documents in a recognizable cartographic tradition, part of the literate archival cultures of the Mediterranean and Europe. The stick charts emerge from an entirely different context, a non-literate society where knowledge was preserved through practice and oral transmission, where the map was a mnemonic tool rather than a permanent record. The precision is there, the charts do encode real wave phenomena with genuine accuracy, but the form is so different that comparison seems almost meaningless. Yet the underlying achievement is analogous, the encoding of geographic knowledge in a form that allows navigation, the representation of the physical world in a way that humans can use to move through that world. The Marshallese navigators solved the same fundamental problem that every cartographer faces: how to reduce the complexity of the environment to a usable representation. But they solved it in a way that no Western tradition ever approached, mapping not the land but the behaviour of water, not static coastlines, but dynamic wave fields. And this raises perhaps the most unsettling question of all. How much knowledge of this kind has been lost? The stick charts survived because the Marshall Islands were contacted by Europeans relatively late, because ethnographers arrived before the traditions had entirely vanished, because some practitioners were willing to explain their knowledge to outsiders. But the Pacific is vast, and the cultures it contained were many, and the colonial period was devastating to indigenous knowledge systems. How many navigation traditions comparable in sophistication to the Marshallese system vanished without record, their practitioners dying before they could transmit their knowledge, their instruments discarded or destroyed by colonizers who saw no value in them? The question applies beyond Polynesia. Every coast in the world was inhabited by peoples who knew their local waters, who navigated by methods suited to their conditions, who accumulated knowledge across generations that enabled survival in challenging marine environments. What did the sailors of the pre-literate Mediterranean know? What techniques guided the coastal peoples of prehistoric India, or the first mariners to cross the Red Sea, or the fishermen who worked the waters off Ice Age Europe when sea levels were lower and coastlines different? All of this is gone, unrecoverable except in the faintest traces. The stick charts survive as a single example of a type of knowledge that must once have existed in countless local variants, each adapted to particular waters, each encoding generations of observation in forms we would barely recognize as maps. Standing before a stick chart in a museum, the geometric framework of palm ribs, the cowrie shells marking invisible islands, one confronts this vast absence. The object on display represents not just Marshallese culture but the shadow of everything we have lost, the knowledge systems that vanished without trace, the sophisticated understanding of the natural world that pre-literate peoples developed and transmitted and ultimately had stripped from them by disease and colonization and cultural disruption. The charts that survive are those that happen to be collected at the right moment, by observers who happen to be curious, in a culture that happened to persist long enough for the collection to occur. Behind every surviving chart stand 1,000 lost traditions, their knowledge irretrievable, their forms unknown. What remains then is layered paradox. The maps we have examined, from the Antarctic coastline of Piri Reis to the wave dynamics of the Marshallese, share a common feature despite their radical differences in form and origin. Each of them contains knowledge that exceeds what we would conventionally expect their makers to possess. Each of them resists fully satisfactory explanation, not because the explanations are inadequate, but because even adequate explanations push the mystery backward rather than resolving it. The Piri Reis map reflects earlier sources that reflected still earlier sources. The stick charts encode knowledge accumulated across generations whose origins are lost. Everywhere we look, we find transmission, inheritance, the layering of tradition upon tradition. And everywhere we look, we find that the earliest layers are invisible, hidden beneath the accumulated sedimentation of centuries, knowable only by their effects on the documents that survive. The conventional historian's task is to explain what can be explained, to identify sources and trace influences, to construct narratives that account for the evidence. This task is valuable and essential, and the explanations it produces are often substantially correct. Piri Reis did have access to earlier maps. Philippe Boichet did extrapolate from incomplete data. The Egyptian scribes did survey their quarries with remarkable precision. The Marshallese navigators did accumulate empirical knowledge of wave dynamics across generations. None of these achievements requires recourse to lost civilizations or supernatural intervention. Human ingenuity, given sufficient time and motivation, proves capable of remarkable feats. But to rest with these explanations is to ignore the questions they open. The sources behind the sources, the knowledge behind the knowledge, the depth of time during which human beings have been observing and representing their world. The maps are fragments, survivors of vast traditions that once existed in fullness and now persist only in scattered remnants. What those traditions contained, how far their knowledge extended, where their chains of transmission ultimately began, these remain open, perhaps permanently open, resistant to the closure that conventional history seeks. The sun sets over the Pacific, as it has set for millions of years over these same waters, over the islands that rise so slightly above the ocean surface, over the wave patterns that persist and repeat in their intricate refractions. The stick chart, that fragile construction of palm and shell, encodes something of what human beings have understood about these patterns, what they learned through generations of watching and feeling and navigating. And somewhere behind that knowledge, beyond the reach of archaeology or oral history, lies its origin, the first observations, the first attempts to teach what had been learned, the first crystallization of fluid intuition into transmissible form. That origin is silent. The ocean, which knows everything, tells us nothing. The waves continue their refractions around islands that do not care whether anyone can read their patterns, and the charts that survive in their museum cases half a world away from the waters they represent wait for interpreters who may never fully understand what they hold. From the Pacific, our attention turns elsewhere, toward cartographic mysteries of different character but no less depth. The maps we have surveyed so far share a common feature. They represent geographic knowledge that can, at least in principle, be verified against physical reality. Coastlines exist or do not exist. Wave patterns refract according to discoverable laws. Geological features either match their representations or fail to match. But there exists another category of cartographic anomaly, maps whose strangeness lies not in their accuracy but in their existence at all. Documents that should not have survived, or that describe regions their makers had no known means to visit, or whose chains of transmission raise questions that have no obvious answers. The thread of inquiry we have followed now leads into darker waters, toward documents whose mysteries compound upon examination, whose layers of paradox resist even provisional resolution. The Vinland map emerged from obscurity in 1957, offered for sale by an antiquarian book dealer in New Haven, Connecticut, bound together with a medieval manuscript known as the Tartar relation. Its parchment appeared old, its ink faded to the brownish tones one would expect of a document centuries removed from its creation. The map itself depicted the Atlantic Ocean and its bordering continents with the imprecision characteristic of medieval cartography. Europe roughly triangular, Africa foreshortened, the Mediterranean bent at implausible angles. But in the upper left corner, beyond the familiar waters, there lay an island labelled Vinlanda Insula, its coastline sketched with apparent confidence, its placement unmistakably corresponding to the northeastern coast of North America. If authentic, the Vinland map would constitute physical proof that Norse geographical knowledge of the New World had been committed to parchment decades before Columbus set sail, that European cartographers possessed awareness of transatlantic landmasses fully half a century before the conventional date of American discovery. The implications rippled outward from the document itself, touching questions of priority and precedence, of what medieval Europe knew and when it knew such things, of how knowledge travels and why it sometimes fails to travel, remaining locked in manuscripts that gather dust while history proceeds as though ignorant of their contents. Yale University acquired the map in 1965 and announced its authenticity with considerable confidence, triggering immediate controversy that has never fully subsided. The debates that followed touched every aspect of the document's existence: the parchment on which it was drawn, the ink with which it was inscribed, the handwriting of its labels, the geographical features it depicted, the provenance through which it had passed before surfacing in the 20th century. Radiocarbon dating of the parchment yielded results consistent with medieval origin, placing the animal skin from which it was prepared sometime around 1434, plus or minus several decades. The parchment at least appeared genuine, a fragment of the medieval world surviving into the modern, carrying whatever had been inscribed upon it through the intervening centuries. But the ink told a different story, or seemed to tell a different story, or told multiple stories depending on who examined it and with what instruments. Microscopic analysis revealed that the ink contained anatase, a crystalline form of titanium dioxide that appeared in certain samples taken from the map's lines. Anatase occurs naturally in some historical pigments, but the particular form detected in the Vinland map ink matched more closely the synthetic anatase used in 20th century paints and coatings, a product of industrial chemistry rather than medieval craftsmanship. Critics seized upon this finding as decisive proof of forgery, arguing that no medieval scribe would have had access to materials bearing the chemical signature of modern manufacturing. The map, they contended, was a clever fabrication, drawn on genuinely old parchment to deceive collectors and scholars, its Norse geography a romantic fiction designed to appeal to those who wished the Vikings had left documentary traces of their American adventures. The controversy seemed settled, the mystery resolved in favour of fraud. Yet the resolution proved unstable. Subsequent analyses yielded contradictory results, some confirming the presence of anatus, others failing to detect it, still others suggesting that the quantities involved were so minute as to be consistent with natural contamination or analytical artifact. The ink's composition remained disputed, its testimony uncertain, its status as evidence shifting with each new examination. Defenders of the map's authenticity noted that anatus can form naturally under certain conditions, that medieval parchment stored for centuries might acquire trace contaminants from its environment, that the absence of anatus in some samples undermined the certainty with which its presence in others had been proclaimed. The scientific debate, rather than resolving the question, revealed the limits of scientific resolution, the difficulty of drawing definitive conclusions from complex materials whose histories of storage and handling introduce variables beyond experimental control. The parchment dates to the 15th century. The ink may or may not contain modern compounds. The map either preserves genuine medieval knowledge or represents an exceptionally sophisticated forgery. The document floats in a liminal space between authenticity and fabrication, neither fully vindicated nor conclusively damned. What makes the controversy so persistent is not merely the technical complexity of the chemical analyses, but the geographical specificity of what the map depicts. The coastline labelled Vinlanda Insula corresponds, in its general configuration, to the actual geography of northeastern North America. Bays indent where bays should indent, Promontories extend where promontories extend. The overall shape, while imprecise by modern standards, suggests genuine knowledge rather than random invention. A forger might easily draw a vaguely island-like shape and label it Vinland, satisfying the romantic expectations of those who wish to believe in Norse cartographic priority. But why would a forger produce a shape that matches, however approximately, the actual continental outline? The precision, such as it is, argues for authenticity, for the transmission of genuine geographical information through chains of copying and recollection whose earlier links have not survived. The medieval Norse certainly reached North America. The archaeological evidence at Lonceau Meadows in Newfoundland establishes their presence beyond reasonable doubt. The question is not whether they possessed geographical knowledge of the regions they visited, but whether that knowledge ever crystallized into cartographic form, ever made the transition from verbal description and navigational memory to lines drawn on prepared animal skin. The Vinland map, if authentic, represents precisely that transition, the moment when what the Norse knew became what European cartographers could see. Standing before the map in its climate-controlled case, one senses the weight of the questions it carries, the decades of scholarly combat that have failed to resolve its status, the frustration of those who have sought certainty and found only deeper ambiguity. The parchment is old, no one seriously disputes this. The ink is problematic, everyone acknowledges this. The geography is suggestive, this too commands general agreement. But the synthesis of these observations into a coherent judgment, authentic or forged, medieval survival or modern fabrication, refuses to coalesce. The map holds its secrets, yielding partial answers to each inquiry, while withholding the final answer that would put all questions to rest. Its existence is itself a kind of cartographic anomaly, a document that maps not only geographical space, but the territory of scholarly uncertainty, the regions where evidence runs thin and interpretation must proceed without secure footing. If the Vinland map is genuine, it tells us that medieval European knowledge of the Atlantic world extended further than surviving documents generally indicate. The chains of transmission existed which the accidents of preservation have largely erased. If it is forged, it tells us something equally interesting about the desires that drive forgery, the yearning for documentary proof of what we already suspect, the willingness to create evidence where evidence is wanting. Either way, the map speaks, to the depths of our uncertainty about medieval knowledge, to the limits of scientific analysis, to the persistence of questions that resist resolution through any available methodology. The controversy continues. New analyses are periodically announced, their results interpreted variously by partisans of authenticity and forgery. The map remains at Yale, displayed occasionally, studied intermittently, neither fully accepted into the canon of medieval cartography nor definitively expelled from it. Its coastlines trace a geography that may be genuine or may be invented, that may represent the distillation of Norse geographical knowledge or the imagination of a 20th century deceiver. The Atlantic waters it depicts remain as they were when the Norse first crossed them: cold, vast, indifferent to questions of cartographic priority. Somewhere beneath those waters, the traces of voyages made and unmade wash back and forth with the tides, resistant to recovery, silent about the documents that did or did not record their routes. The Vinland map, whatever its origins, participates in this silence, offering what appears to be knowledge while withholding the certainty that would make that knowledge secure. From the contested parchment of the Vinland map, we turn to another medieval document whose authenticity is beyond question, but whose contents present mysteries of a different order. The Framauro Mappa Mundi, completed around 1450 in the Venetian monastery of San Michele di Murano, represents perhaps the greatest achievement of medieval European cartography. A vast circular image nearly 2 meters in diameter, depicting the entire known world in extraordinary detail. Framauro, a Camaldolese monk whose life was devoted to the gathering and synthesis of geographical knowledge, drew upon sources ranging from classical texts to contemporary travellers' reports, from Ptolemaic geography to the accounts of merchants who traded in ports from Lisbon to China. The map he produced synthesized this accumulated knowledge into a single comprehensive image, a visual encyclopedia of the world as 15th century Venice understood it. But within that synthesis, there appear details whose sources have never been satisfactorily identified, geographical features whose accuracy seems to exceed what Framauro's known sources could have provided. The African continent, as Framauro depicted it, shows the southern cape curving eastward in a manner broadly consistent with the actual geography of the Cape of Good Hope, a feature that European navigators would not round until Bartolomeu Dias in 1488, nearly 4 decades after the map's completion. Fra-Mauro's Africa is imprecise, its proportions distorted, its coastlines generalised, but the fundamental shape is there, the continent narrowing toward its southern terminus, the land ending and the ocean continuing. How did a Venetian monk compiling his map from sources available in mid-15th century Italy arrive at a representation of African geography that anticipated discoveries not yet made? The question admits several conventional answers. Arab traders had long navigated the Indian Ocean, and their geographical knowledge, transmitted through mercantile networks, may have reached Venice through channels that leave no documentary trace. Chinese voyages under Zheng He, which reached the East African coast in the early 15th century, might have contributed to a circulating body of geographical information about the African landmass. Portuguese exploration, though it had not yet rounded the Cape, had pushed progressively southward along the African coast, and intelligence from these voyages might have reached Fra-Mauro through diplomatic or commercial contacts. The monk himself, in the extensive Latin inscriptions that cover his map, acknowledges drawing upon information from travellers and merchants, from those who had seen with their own eyes the regions they described. Yet the precision of certain features continues to invite reflection. The Zambezi and Limpopo rivers appear on Fra-Mauro's map in approximately their correct positions, draining into the Indian Ocean along the southeastern African coast. The Great Lakes of East Africa are suggested, though their shapes are imprecise. These interior features, far from any coast where European ships might have gathered intelligence, imply sources whose depth of African geographical knowledge exceeded what casual coastal observation could provide. Arab geographers had written of the African interior, drawing on information from trans-Saharan trade routes and East African commercial networks. These texts were available, at least in part, to European scholars, but the correlation between Fra-Mauro's representations and actual geography, while imperfect, exceeds what mere interpolation from incomplete sources would be expected to produce. The map seems to know more than its documented sources explain, to synthesize information whose ultimate origins remain obscure. One inscription on the map has attracted particular attention. Fra-Mauro records that an Indian junk or ship from the east had sailed far to the south and west, beyond the Cape of Africa, into waters that would not be traversed by European vessels for another half-century. The details of this voyage, as Fra-Mauro reports them, suggest a circumnavigation of Africa from east to west, a journey that, if it occurred, would represent one of the great unrecorded maritime achievements of the pre-modern world. The source of this information is unclear. Fra-Mauro attributes it to second-hand report, to the testimony of those who had heard of such a voyage without having participated in it themselves. The inscription floats on the map like a message from a world of maritime exploration that exists outside the documentary record, a hint that the oceans held more traffic than surviving archives indicate, that ships from eastern lands may have probed waters that European cartographers assumed empty and unexplored. The Fra-Mauro map hangs today in the Biblioteca Nazionale Marciana in Venice, its colours faded but still visible, its thousands of inscriptions still legible to those who bend close enough to read them. Its surface is crowded with images, cities rendered as clusters of towers, ships sailing on painted seas, figures of rulers and merchants engaged in the business of distant lands. The wealth of detail overwhelms, inviting prolonged examination, rewarding attention with ever more particularities of representation. And yet, amid all this specificity, the map's sources remain partially obscure, its syntheses not fully traceable to their constituent inputs. Fra-Mauro gathered information from everywhere he could reach, compiled it with the patience of a lifetime's devotion, produced an image that represented the sum of mid-15th century geographical knowledge. But within that sum, there appear terms whose origins he himself may not have fully known, data points whose chains of transmission extended beyond his ability to trace them. The map is both culmination and mystery, the endpoint of one tradition of knowledge gathering and the beginning of questions that have never been fully answered. Standing before the map in its Venetian display, one feels the presence of the monk who made it, the years of careful compilation, the correspondence with travellers and merchants, the sifting of reports for reliability and consistency. Fra Mauro's map is not a document of lost civilizations or impossible knowledge. It is a document of painstaking scholarship, of the attempt to synthesize disparate sources into coherent representation. But that very synthesis reveals the limits of what can be traced. The rivers of Africa were known to someone, the shape of the southern cape was known to someone, the voyage of the Indian junk was known to someone. Fra Mauro recorded what reached him, without always knowing where it had originated or through how many hands it had passed. His map is a palimpsest of transmissions, a layering of knowledge upon knowledge, each layer partially obscuring the layers beneath while preserving their effects in the configurations it displays. The mystery of the Fra Mauro map is not the mystery of the Vinland map. No one doubts its authenticity. No one suspects forgery. No chemical analyses trouble its status as a genuine product of 15th century Venetian cartography. The mystery lies instead in the depth of knowledge it appears to contain, the accuracy of representations whose sources remain uncertain, the hints of maritime voyages and geographical surveys whose documentary traces have not survived. The map is a window into a world of information exchange that operated largely beneath the level of written record, where merchants shared what they had seen with other merchants, where travellers reported their observations to those who would synthesize them into larger images, where knowledge accumulated and circulated through channels that leave few traces in archives. Fra Mauro's achievement was to capture some portion of this circulating knowledge, to freeze it into cartographic form, to preserve it against the erasure that time inflicts on oral transmission. But what he captured was already a fraction of what existed, already a selection from a larger pool of geographical information whose full extent we cannot recover. The sun sets over Venice as it has set for centuries, gilding the waters of the lagoon, casting long shadows through the windows of the Biblioteca Marciana. The map hangs in its case, patient and silent, waiting for scholars who may never fully trace its sources, who may never reconstruct the complete network of informants and transmitters through which its data flowed. Fra Mauro's Africa points southward toward a cape that European ships would not round until nearly 4 decades after his death, toward waters that his monk's life never allowed him to see. The Indian junk sails on its inscribed voyage, somewhere beyond the edge of documentation, carrying whatever it carried toward destinations that history has not preserved. And the map itself, that great circular synthesis, remains both monument and enigma. Monument to what mid-15th century scholarship could achieve, enigma to those who wonder how it achieved quite so much with the sources we can identify. The vellum holds its ink, the inscriptions preserve their Latin phrases, the rivers flow toward their painted seas, but the knowledge behind the knowledge, the chains of transmission that brought information from the interior of Africa to a monastery on a Venetian island, remain largely invisible, traceable only through their effects on the document that survives. From the Fra Mauro Mappa Mundi, we follow the thread of cartographic mystery backward in time, toward a document whose antiquity dwarfs even the medieval achievements we have surveyed. The Turin Papyrus, discovered in fragments and reassembled with painstaking care, dates to approximately 1150 BCE, to the reign of Rameses IV of Egypt's 20th dynasty. It is the oldest surviving geological map in the world, and its existence raises questions about the depth and sophistication of ancient Egyptian knowledge that conventional accounts sometimes underestimate. The papyrus depicts a region of the eastern desert, the mountainous terrain between the Nile Valley and the Red Sea, where Egyptian expeditions travelled to quarry stone and mine gold. The map shows wadis, dry riverbeds that channel occasional floodwaters, winding through terrain rendered with attention to geological detail. Different rock types are indicated by different colours: the pink granite of the mountains, the black stone of the Bekan quarries, the golden yellow of the desert sands. The proportions are not modern, the scale is not consistent, but the essential features of the landscape are there, recognisable to those who have walked the same terrain 3,000 years later, corresponding to geological surveys conducted with instruments the ancient cartographers could never have imagined. What arrests attention is not merely the existence of such a map. Egyptian administrative sophistication makes the development of cartography unsurprising, but the precision of its geological distinctions. The ancient mapmakers differentiated between rock types with an accuracy that implies systematic observation, the kind of careful attention to material properties that one associates with geological science rather than casual inspection. The Bekan stone that the map depicts, a Greyvacker prize for statuary, occurs in specific formations whose extent the papyrus correctly indicates. The gold-bearing regions are marked with appropriate symbols, their locations corresponding to deposits that modern surveys have confirmed. The wadis follow their actual courses, draining the highlands toward lower ground as wadis do, carrying the memory of rare rains toward the distant sea. The conventional explanation presents this map as a practical document, a working tool for an expedition that Rameses IV dispatched to quarry stone for temple construction. And this explanation is almost certainly correct in its essentials. The papyrus bears annotations referring to the expedition's objectives, to the beacon stone that was its target, to the gold deposits that made the region valuable. Administrative records from the same period confirm that such expeditions were regular occurrences, that the Egyptian state invested considerable resources in extracting materials from the eastern desert, that the infrastructure of quarrying and mining required logistical planning of substantial complexity. The map in this reading is simply what it appears to be, a document prepared to guide workers and administrators through unfamiliar terrain, to show them where the valuable deposits lay, to orient them in a landscape where landmarks are few and the consequences of becoming lost are severe. Yet certain aspects of the Turin Papyrus invite reflection that extends beyond its immediate administrative purpose. The geological precision is one such aspect. The ancient cartographers did not merely sketch the general outline of the terrain, they distinguished between rock types with an accuracy that suggests systematic geological knowledge. The beacon stone formations are rendered in their correct extent and position. The granite intrusions are differentiated from the sedimentary rocks that surround them. The gold-bearing quartz veins are indicated with symbols that correspond to actual mineralization patterns still observable today. This is not the casual observation of travellers passing through. It is the product of sustained attention to the material composition of the landscape, the kind of attention that requires both expertise and method. How did the ancient Egyptians acquire such knowledge? The conventional answer points to the accumulated experience of generations of expeditions, to the practical wisdom of miners and quarrymen who worked the deposits over centuries, to the gradual development of empirical knowledge through trial and observation. And this answer is plausible, even probable. Peoples who work closely with stone over many generations develop an intimate understanding of its properties, its variations, its distribution. The geological knowledge encoded in the Turin Papyrus could represent nothing more than the formalization of craft wisdom, the translation of practical experience into cartographic form. But the precision still raises questions. Modern geological surveys of the Wadi Hammamat region, conducted with satellite imagery and ground truthing expeditions, have confirmed the accuracy of the ancient map's geological distinctions. The rock-type boundaries align with contemporary geological maps, to a degree that seems to exceed what casual observation could achieve. The beacon stone deposits occur precisely where the papyrus indicates they should occur. The gold-bearing regions correspond to areas where modern mining operations have extracted precious metals. The wadis follow courses that 3,000 years of erosion have not significantly altered. Was this precision the product of accumulated experience alone, or did the ancient Egyptians possess methods of geological investigation whose sophistication we have underestimated? The question resists definitive answer. The papyrus itself provides no explanation of how its data were gathered, no indication of the surveys or inspections that must have preceded its creation. Like so many ancient documents, it presents its information as given, as already known, without revealing the processes through which knowledge became knowledge. The geological distinctions appear on the papyrus fully formed, their origins invisible, their epistemological history unrecoverable. What compounds the mystery is the apparent absence of comparable documents from the intervening millennia. The Turin Papyrus stands alone, the only geological map to survive from the ancient world, its uniqueness raising questions about whether it represents the fortunate survival of a single document from a larger tradition, or whether it was itself exceptional, a singular achievement whose methods died with its creators. Geological mapping as a systematic discipline would not re-emerge until the 18th century, when European naturalists began to classify rocks and trace formations with methods that would eventually produce the geological sciences we know today. For 3,000 years, the kind of knowledge encoded in the Turin Papyrus seems to have left no comparable traces, to have existed, if it existed at all, only in forms that time has erased. The papyrus rests now in the Museo Egizio in Turin, its fragments reassembled by 19th century scholars who recognised what they held, its painted surface still legible after more than 3 millennia. The pink granite, the black beacon stone, the yellow desert sands retain their colours, their distinctions still visible to modern eyes. And the landscape they depict waits in the eastern desert, unchanged in its essential features, its wadis still channeling the rare rains, its rock formations still bearing the same properties that ancient cartographers recorded with such unexpected precision. Standing in that desert today, one could hold a copy of the ancient map and trace the features it describes, could walk the wadis that Egyptian expeditions walked, could find the stone deposits where the map indicates they should be found. The correspondence would be imperfect. 3,000 years leave their marks on any landscape, but the essential accuracy would persist, would demonstrate that whatever methods produced this map, they captured something real, something durable, something that time has not erased. The Turin Papyrus points backward toward questions about the depth of ancient knowledge, but it also points forward toward a different kind of cartographic puzzle, the question of how ancient peoples conceptualized the world itself, the cosmos within which their practical surveys took place. From the geological precision of Egyptian mining maps, we turn to a very different document, one that makes no claim to practical accuracy but whose conceptual framework reveals assumptions about the shape and structure of the world that deserve careful attention. The Babylonian world map, known to scholars as Imago Mundi, dates to approximately the 6th century BCE, though it may copy an older original whose date cannot be determined. It was discovered in the ruins of Sippar, a city sacred to Shamash, the Babylonian sun god, and it presents a view of the world that differs fundamentally from modern geographical understanding. The map is circular, bounded by a salt sea that encircles the known lands like a protective moat. Babylon sits at the centre, as one might expect, the navel of the world as its inhabitants understood it. The Euphrates River flows through the disk of land, connecting regions whose names appear in cuneiform labels. Mountain ranges rise at the edges. Beyond the encircling ocean, triangular projections extend outward like rays, labelled with descriptions of distant lands where strange creatures dwell and where the sun rises and sets in its eternal circuit. The conventional interpretation of this map is straightforward. It is a cosmological diagram, a representation of the world as Babylonian mythology understood it, not an attempt at accurate geography. The triangular projections correspond to mythological regions described in epic literature, to lands beyond the edge of the known where heroes journeyed and where gods made their homes. The circular form reflects cosmological rather than geographical thinking, the idea that the world is an ordered disk surrounded by primordial waters, held in place by divine power. To read this map as geography, in the modern sense, would be to misunderstand its purpose, to impose categories that its creators would not have recognised. And yet the map contains elements that resist purely cosmological interpretation. The placement of cities and features within the central disk corresponds, at least roughly, to actual geographical relationships. Babylon is correctly positioned relative to Assyria, to the mountains of the north, to the Persian Gulf in the south. The Euphrates flows in its proper direction. The swamps of the south appear where swamps actually existed. These are not the features of pure mythology. They are the features of observed geography, simplified and stylized but grounded in real spatial relationships that Babylonian administrators and merchants would have known from practical experience. The tension between the cosmological frame and the geographical content raises questions about how the ancients understood the relationship between these two modes of representing the world. Were they distinct categories that modern scholars have artificially separated, or did they blend seamlessly in ancient thought, the practical and the mythological coexisting without contradiction? The Babylonian world map suggests the latter, suggests that for its creators, the world was simultaneously a geographical space to be navigated and a cosmological structure to be understood, that the triangular projections and the encircling ocean were as real, in their way, as the cities and rivers of the central disk. What makes this document relevant to our inquiry is not its accuracy. By modern standards, it is wildly inaccurate, but what it reveals about the conceptual frameworks within which ancient cartography operated. The Babylonians who created this map possessed sophisticated astronomical knowledge mathematical systems capable of predicting celestial events with remarkable precision, administrative records that tracked resources across a vast empire. They were not naive, they were not ignorant, yet their representation of the world looks nothing like modern maps, seems to belong to a different category of document entirely. The gap between Babylonian astronomical precision and Babylonian geographical representation raises questions about the selectivity of ancient knowledge, about why some domains developed with such sophistication, while others remained embedded in mythological frameworks. Or did they? The triangular projections beyond the encircling sea are labelled with distances, with descriptions that suggest not pure fantasy, but reports of actual journeys, however distorted by transmission. One projection describes a region where the sun is not seen, where darkness prevails, a description that could correspond to lands of the far north, where winter nights extend for months. Another describes a region of perpetual light, perhaps the same northern lands in their summer phase, the midnight sun that Arctic travellers know. These descriptions could be pure mythology, conventional elements of cosmological literature repeated without geographical basis. But they could also preserve echoes of actual reports, of information that reached Babylon through trade networks, that extended far beyond the empire's borders, information that was absorbed into mythological frameworks because no other frameworks existed to contain it. The Babylonian world map hangs suspended between cosmology and geography, between mythology and observation, its precise meaning irrecoverable because the conceptual categories of its creators are no longer accessible to us. We can translate the cuneiform labels, we can identify the cities and rivers named, we can trace the cosmological motifs to their literary sources. But the living understanding that made this document meaningful to those who created it, the way in which it functioned within their mental world, the precise status they accorded its various elements, these remain elusive, glimpsed only through the inadequate filter of modern interpretation. The clay tablet rests in the British Museum, its surface inscribed with lines and labels, patient and silent, offering its enigmas to scholars who may never fully resolve them. From the conceptual puzzles of ancient cosmographical representation, we journey across an ocean of time and space to encounter a cartographic tradition unlike any we have yet examined. The Polynesian stick charts of the Marshall Islands are not maps in the conventional sense. They do not represent coastlines or land masses. They carry no names, no labels, no written information of any kind. To untrained eyes, they appear as nothing more than frameworks of sticks and shells, abstract constructions whose purpose is entirely opaque. Yet these objects encode navigational knowledge of such sophistication that modern oceanographers have only recently begun to understand how they work, and the precision they achieve challenges assumptions about the limits of human perception and the possibilities of non-literate knowledge systems. The Marshall Islands are scattered across a vast expanse of the Pacific Ocean, tiny atolls separated by hundreds of miles of open water, with no landmarks to guide the voyager. The islands are so low-lying that they cannot be seen from any significant distance. A canoe could pass within miles of an atoll and miss it entirely if the navigator did not know precisely where to look. Yet for centuries, perhaps millennia, Marshallese navigators crossed these waters regularly, travelling between islands without compass, without sextant, without any of the instruments that Western navigation considers essential. How they accomplished this feat remained mysterious to outside observers until researchers began to examine the stick charts that navigators created and used. The sticks represent not islands but ocean swells, the patterns of waves that ripple across the Pacific, generated by distant storms and refracted by the presence of land masses. When ocean swells encounter an island, they bend around it, reflecting and interfering in patterns that extend far beyond the island's visible presence. A skilled navigator, trained from childhood to read these patterns, can detect the presence of an unseen island by the way the waves beneath the canoe change their rhythm and direction. The shells on the stick chart mark the positions of islands. The sticks map the swell patterns that connect them, the invisible pathways of wave refraction that transform the trackless ocean into a readable text. This is navigation by water, not by stars or landmarks. The navigator does not look up to find position. The navigator feels down, reading the motion of the canoe through subtle variations in pitch and roll, through the way the hull responds to crossing swells, through rhythms that only years of training can make legible. The stick chart is a teaching tool and a memory aid, a way of encoding knowledge that must ultimately be embodied, that must become part of the navigator's physical being before it can be used. Once learned, the charts themselves are unnecessary. The knowledge lives in the body, in the trained sensitivity to motion that allows a master navigator to cross hundreds of miles of open ocean and arrive at a tiny atoll invisible over the horizon. The conventional explanation of Polynesian navigation emphasizes the practical. These techniques developed because they were necessary, because survival required the ability to travel between islands, because the environment forced innovation in the absence of alternatives. And this explanation is almost certainly correct. Necessity is a powerful driver of invention, and the Polynesians faced navigational challenges that demanded solutions. The stick charts represent one such solution, developed over generations through trial and refinement, through the accumulation of experience into transmissible knowledge. Yet the sophistication of swell navigation raises questions that practical necessity alone does not fully answer. The wave patterns that the stick charts encode are real physical phenomena, describable by modern oceanography in terms of wave refraction, diffraction, and interference. But the Marshallese navigators developed their understanding without access to the mathematical frameworks that modern oceanographers use, without instruments to measure wave heights or periods or directions. They developed it through observation alone, through the patient accumulation of experiential knowledge that eventually produced a working model of oceanic behaviour, accurate enough to stake lives upon. How was this knowledge systematized? How were the patterns recognized, classified, transmitted? The stick charts themselves provide no explanation, no theoretical framework, no principles of wave physics. They simply encode the results of knowledge without revealing its epistemological foundations. A modern oceanographer could study a stick chart and recognize the wave patterns it represents, could verify their accuracy against hydrodynamic models, could confirm that the charts depict real phenomena. But the same oceanographer could not reconstruct the process by which this knowledge was originally acquired, the conceptual steps through which untrained perception became expert reading, the methods by which individual observations were integrated into systematic understanding. The precision of swell navigation has been confirmed by modern research. Navigators trained in traditional methods have successfully crossed open ocean using only swell reading, arriving at target islands with accuracy that matches or exceeds GPS navigation under certain conditions. The wave refraction patterns are real. The islands do disturb the swells in predictable ways. The trained body can detect these disturbances with remarkable sensitivity. What seemed to outside observers like magic or myth has been verified as applied physics, as practical knowledge grounded in accurate observation of natural phenomena. But verification of accuracy does not explain acquisition. The question that persists is how this knowledge was originally developed, how navigators without instruments or theory came to understand wave physics well enough to navigate by it. The answer, presumably, lies in the deep time of Polynesian seafaring, in the thousands of years during which Pacific peoples explored their oceanic world, in the countless voyages whose successes and failures gradually refined a tradition of knowledge that eventually produced the stick charts we can examine today. But this answer, while plausible, remains somewhat unsatisfying because it pushes the mystery backward in time without resolving it, because it explains the transmission of knowledge without explaining its origin. The stick charts hang in museums now, collected by anthropologists who recognized their significance before the knowledge they encoded was entirely lost. The shell-marked intersections represent atolls whose names the charts do not record, whose positions are fixed not by coordinates, but by the swell patterns that connect them to their neighbours. The curved sticks trace pathways through water, through motion, through the physical medium of the ocean itself, transformed by human observation into a navigable text. Standing before these objects, one confronts a tradition of knowledge utterly different from the cartographic traditions of Europe or the Middle East, a way of representing the world that has no equivalent in the documents we have previously examined, yet achieves comparable or superior results within its domain. The Polynesian achievement raises questions about the diversity of human approaches to spatial knowledge, about the multiple ways in which peoples have encoded geographical understanding, about the untranslatable differences between knowledge systems that cannot be directly compared. The stick charts and the Piri Reis map represent the same fundamental challenge, the problem of navigating across spaces too large to be seen at once, but their solutions share almost nothing beyond their effectiveness. They emerge from different environments, different technologies, different conceptual frameworks, different relationships between knowledge and embodiment. They cannot be ranked on a single scale of accuracy or sophistication. They can only be appreciated as different flowers from the same garden of human ingenuity, different responses to the universal challenge of finding one's way across the surface of a world too large to be grasped in a single glance. The shells sit in their matrix of sticks, patient and silent. The swells roll across the Pacific as they have rolled for millennia, bending around islands, carrying information that only trained bodies can read. The navigators who could read them are nearly gone now, their knowledge surviving mainly in academic reconstructions and museum displays. The tradition that produced the charts has thinned to a thread, maintained by a handful of practitioners who struggle to transmit what they know to successors who may never need it, who have GPS and engines and charts printed with coordinates and depth soundings. The ocean remains, the islands remain, the swells continue their endless refraction. But the knowledge that transformed these physical phenomena into a navigation system, that knowledge is fading, is becoming historical, is joining the lost techniques that our journey has repeatedly encountered. From the embodied knowledge of Pacific navigation, we must eventually step back to consider what our cartographic survey has revealed. What patterns emerge from the comparison of documents so various in their origins, their methods, their purposes? The Piri Reis map and its ice-free Antarctica, the Zeno map and its subglacial topography, the Boache map and its divided southern continent, the contested Vinland map, from Arrow's African Cape, the Turin Papyrus and its geological precision, the Babylonian cosmological disk, the Polynesian stick charts. These documents span millennia and continents, emerge from traditions that had no contact with each other, address problems that range from oceanic navigation to theological cosmology to practical mining. What, if anything, do they share? What conclusions, if any, can their collective testimony support? The answer is not simple, and perhaps that is the point. Perhaps the most honest conclusion our journey permits is that the history of human geographical knowledge is stranger, deeper, and more discontinuous than the neat narratives of progressive discovery would suggest. Each document we have examined presents an anomaly, a moment where the map seems to exceed the mapmaker, where the representation contains information that the tools and circumstances of its creation should not have allowed. The Piri Reis map depicts a coastline that should have been invisible beneath miles of ice. The Zeno map traces features that would not be confirmed until the 20th century. The Boache map divides a continent whose division would not be established for another 2 centuries. Framauro draws an African cape decades before any European vessel rounded it. The Turin Papyrus records geological formations with a precision that modern surveys have confirmed. The Babylonian world map encodes cosmological knowledge whose mathematical sophistication continues to reward analysis. The Polynesian stick charts navigate without instruments through wave patterns invisible to the untrained observer. In each case, the conventional explanations are available, and in each case, they fall slightly short of complete satisfaction. The anomalies may be coincidences, lucky guesses, misinterpretations of conventional sources, products of transmission from earlier documents that have since been lost. Each mystery, taken individually, admits a prosaic solution that requires no appeal to lost civilizations or vanished technologies. But taken collectively, the documents begin to suggest a pattern, a recurring phenomenon that deserves consideration even if it cannot be definitively explained. The pattern might be called the persistence of accuracy across gaps in transmission, the survival of precise geographical information through periods when the knowledge required to generate that information had supposedly not yet been acquired or had already been lost. The Piri Reis map, to take the most famous example, depicts the Antarctic coastline as it existed before the ice sheet formed, a coastline that has been buried for thousands of years at minimum. The conventional explanation holds that the apparent Antarctic features are actually a distorted rendering of the South American coast, extended and curved to fill the space that Renaissance cartographers believed must contain a southern continent. This explanation is entirely reasonable. The distortions visible in the surviving fragment of the map could easily produce the appearance of Antarctic features that were never intended. The coincidence between the depicted coastline and the actual subglacial topography could be just that. A coincidence statistically improbable, but not impossible when one considers the millions of maps that humanity has produced over the millennia. If we examine enough maps, we will inevitably find some that accidentally predict features not known to their creators, just as we will find cloud formations that resemble human faces or rock outcrops that suggest ancient constructions. Yet the coincidence in the Piri Reis map is extraordinarily precise. The correlation between the depicted coastline and the subglacial topography, as revealed by modern ice-penetrating radar surveys, extends to individual bays and peninsulas, to the proportions of land masses, to the angles at which features meet. If this is coincidence, it is coincidence of a very high order, the cartographic equivalent of a monkey typing Shakespeare. The statistical probability of such accuracy arising from distortion and imagination alone has never been calculated, but intuition suggests it must be exceedingly small. Something more than accident seems to be at work, some source of information that we have not identified, some transmission pathway that we have not traced. The same pattern appears in the Zeno map, though with different details and different conventional explanations. The Zeno map depicts Greenland with remarkable accuracy, including features that would not be confirmed until modern surveys penetrated the ice sheet to reveal the rock beneath. The conventional explanation holds that the Zeno brothers drew on actual voyages to the North Atlantic, supplemented by reports from other travellers and the usual cartographic imagination of their era. The accuracy of the map on this reading reflects the genuine geographical knowledge available to skilled navigators of the late medieval period, knowledge that was subsequently lost during centuries when European interest in the North Atlantic declined. The subglacial features that seem to appear on the map are, like those on the Piri Reis map, probably misinterpretations of surface features, coincidences that appear significant only because we examine the map with modern knowledge that its creators lacked. But again, the coincidences multiply beyond comfortable probability. The rivers that appear on the Zeno map flowing across a Greenland depicted without its ice sheet correspond to drainage channels that modern surveys have confirmed exist beneath the ice. Channels that have been buried for thousands of years and would have been entirely invisible to any medieval observer. The mountain ranges that the map suggests in Greenland's interior correspond to subglacial peaks that ice-penetrating radar has revealed in approximately the positions the map indicates. The coastline details that the map provides, details ostensibly observed from ships sailing along Greenland's shores, include features that would only be visible if the ice sheet did not exist. Features that are now confirmed to exist beneath miles of frozen water. Either the Zeno brothers had access to information about Greenland's subglacial topography, information that could only have been gathered when the topography was exposed to observation, or we are witnessing a coincidence so improbable that it strains credulity. The Boache map presents the same mystery in yet another form. Philippe Boache depicted Antarctica as two landmasses separated by a strait, a configuration that 20th century surveys would confirm exists beneath the ice. Boache's map dates from 1737, more than 2 centuries before ice-penetrating technology would reveal the subglacial geography he seems to have anticipated. The conventional explanation holds that Boache was simply indulging the speculative cartography of his era, filling in unknown regions with features that seemed geographically plausible, much as other cartographers of his time invented mountain ranges and rivers for the interiors of continents that Europeans had not yet explored. The division of Antarctica into 2 land masses was, on this reading, a lucky guess, one among many guesses that Boache made, most of which proved incorrect. We remember this guess because it happened to be right. We forget the many errors that surrounded it. Yet the precision of Boache's depiction extends beyond the simple fact of Antarctica's division. The strait he depicts separating the 2 land masses corresponds with remarkable accuracy to the location and dimensions of the subglacial trough that modern surveys have revealed. The shape of the 2 land masses, their relative sizes, the angles at which their coastlines meet the separating waters, all these details find confirmation in the topography that would not be measured for another 2 centuries. Boache was guessing, yes, but he was guessing with uncanny accuracy, producing details that random speculation could not reasonably have generated. The map suggests access to information, genuine geographical knowledge that the 18th century should not have possessed. And so the pattern continues through each document we have examined. Fra Mauro depicts the southern Cape of Africa decades before Portuguese vessels rounded it, and his depiction includes details that suggest actual observation rather than theoretical inference. The Turin Papyrus records geological formations with a precision that modern surveys have confirmed, as if its ancient Egyptian creators had access to instrumental measurements of bedrock composition and mineral distribution. The Babylonian world map encodes cosmological and geographical knowledge within a symbolic framework whose mathematical sophistication continues to reward scholarly analysis. The Polynesian stick charts navigate using wave patterns that require years of embodied training to perceive, representing a form of knowledge that cannot be translated into the coordinate-based systems that Western cartography employs. In each case, the map contains information that its creators should not have had, knowledge that exceeds the tools and methods supposedly available to them, accuracy that the conventional narratives of geographical discovery cannot easily explain. What conclusions might we draw from this recurring pattern? Several possibilities present themselves, each with different implications for our understanding of human history. The first possibility is that the anomalies are indeed coincidences, statistical outliers that appear significant only because we have selected them for examination, while ignoring the far more numerous maps that contain no such anomalies. On this reading, the Piri Reis map, the Zeno map, the Boacha map, and the others are unusual only in the sense that any sufficiently large sample will contain unusual specimens. If we examined thousands of Renaissance maps depicting unknown regions, we would find a few whose speculative features accidentally corresponded to geographical realities. We remember these maps precisely because of their anomalous accuracy. We forget the far more numerous maps whose guesses proved entirely wrong. This is the principle of survivorship bias, applied to cartographic history. The anomalies are artifacts of our selection process, not evidence of lost knowledge. This explanation is parsimonious and reasonable, and it may well be correct, but it does not entirely satisfy, because the anomalies in the maps we have examined are not of the kind that survivorship bias would predict. Random guesses about unknown regions would produce occasional accidental correspondences with reality. Yes, but those correspondences would be scattered and fragmentary, not systematic and detailed. A monkey typing at random might occasionally produce a recognizable word, but it will not produce syntactically correct sentences, much less coherent paragraphs. The anomalies in our maps are more like sentences than words, extended, structured, internally consistent correspondences that seem to reflect actual knowledge rather than lucky guessing. The ice-free coastline of the Piri Reis map extends for hundreds of miles, maintains consistent proportions, and includes individual features that correspond to confirmed subglacial topography. This is not the kind of pattern that random error produces. The second possibility is that the maps preserve genuine ancient knowledge transmitted through channels that subsequent history has obscured. On this reading, ancient peoples possess geographical information that modern scholars have attributed only to recent discoveries, information about ice-free Antarctica, about subglacial Greenland, about the southern Cape of Africa, about geological formations invisible to surface observation. This knowledge was recorded in documents that have since been lost, but fragments of it survived through copying, through oral tradition, through the preservation of earlier maps that Renaissance cartographers consulted without fully understanding their significance. The Piri Reis map would then be a palimpsest, a surface document layered over sources far more ancient than itself, preserving traces of knowledge that originated in eras when Antarctica was ice-free and Greenland's topography was exposed. This explanation raises obvious questions about how such ancient knowledge could have been acquired. If Antarctica was ice-free when the source documents were created, that ice-free period ended many thousands of years ago, far earlier than any civilization known to archaeology. Who created the original surveys? How did they travel to the Antarctic coast? What technology did they use to map features that even Renaissance ships could not have reached? These questions lead quickly into speculative territory, into hypotheses about lost civilizations possessing technologies more advanced than conventional archaeology recognizes. Such hypotheses are not impossible, but they require evidence that archaeology has not yet provided. The maps themselves might constitute such evidence, but using the maps to prove the existence of lost civilizations, and then using those civilizations to explain the maps, threatens circularity. A third possibility occupies a middle ground between coincidence and lost civilization. Perhaps the maps reflect knowledge that was indeed available to their creators, but through channels that conventional history has underestimated. Perhaps medieval and Renaissance navigators travelled farther and learned more than the surviving records indicate. Perhaps oral traditions among sailing peoples preserved geographical information for centuries or millennia before that information was committed to parchment. Perhaps the accumulation of navigational experience across generations, transmitted through informal channels that left no documentary trace, produced knowledge that academic histories focused on written sources have failed to recognise. On this reading, the maps are anomalous only relative to our imperfect reconstruction of past knowledge. They are not anomalous relative to what past peoples actually knew. This explanation is appealing because it does not require appeal to lost civilizations or supernatural powers, only to the limitations of historical method. We know that our knowledge of past navigational practice is incomplete. We know that sailors transmitted knowledge orally, through apprenticeship and practice, in ways that rarely produced written records. We know that coastal peoples accumulated geographical information across many generations, gradually building mental maps of their maritime environments that far exceeded what any individual voyage could have discovered. The precision of the Polynesian stick charts demonstrates that non-literate peoples could achieve remarkable geographical accuracy through the accumulation of embodied experience. Perhaps similar processes operated in other times and places, producing knowledge that literate observers recorded without understanding its origins. But this explanation too has limitations. The features that some of our maps depict were not merely unknown to recorded history, they were physically inaccessible to observation. The subglacial topography of Antarctica and Greenland was buried beneath miles of ice during any period when humans might have observed it. The geological formations recorded in the Turin Papyrus required exposure of bedrock that would not naturally occur. Fromauro's African Cape could theoretically have been reached by medieval ships, but the Boache maps divided Antarctica, and the Piri Reis maps' ice-free coastline depict features that no historical navigation could have revealed. The explanation from accumulated navigational experience works well for some anomalies, but not for others. The most striking correspondences between ancient maps and modern surveys remain unexplained, and so we return to mystery, which is perhaps the appropriate destination for a journey of this kind. The maps we have examined resist definitive interpretation. Their anomalies may be coincidences, but coincidences of improbable precision. They may reflect lost knowledge, but knowledge whose origins we cannot trace. They may reveal gaps in our historical understanding, but gaps that point toward experiences that the historical record cannot confirm. The documents hang in archives and museums, patient and silent, inviting examination but refusing final answers. The coastlines they depict correspond to features confirmed by modern technology. The formations they record match surveys conducted centuries after their creation. The navigation systems they encode achieve accuracy that Western instrumentation has only recently replicated. But how? Through what channels of transmission? From what original observations? The questions accumulate without resolution, and perhaps that accumulation is itself the point. Perhaps the most important function of anomalous maps is not to provide answers, but to maintain questions, to keep open the possibility that human history is stranger and deeper than our reconstructions have recognized. The maps are doorways, thresholds, liminal documents that stand between what we know and what we cannot explain. They invite us into uncertainty, and uncertainty is not a comfortable destination, but it may be an honest one. The history of human knowledge is not a simple progression from ignorance to understanding. It is a complex tapestry of discovery and forgetting, of transmission and loss, of knowledge that appears and vanishes and sometimes reappears in unexpected forms. The anomalous maps are threads in that tapestry, coloured threads that catch the light and draw the eye, reminding us that the pattern is not yet complete, that weaving continues in ways we do not fully understand. The Piri Reis map remains in Istanbul, its fragmentary parchment preserved under controlled conditions, its depicted coastlines still debated by scholars who cannot agree on what they represent. The Zeno map has been studied and restudied, defended and attacked, its authenticity still contested after centuries of examination. The Boache map hangs in collection, its divided Antarctica now confirmed by surveys that Philippe Boache could never have imagined. The Vinland map, whether genuine or forged, has generated more scholarly literature than most authenticated medieval documents. Fra Mauro's great Mappa Mundi spreads across its circular frame, depicting a world that was still being revealed when its creator set down his brushes. The Turin Papyrus records a landscape that has not fundamentally changed since its ancient surveyors traced its wadis and mountains. The Babylonian world map encodes a cosmos that its creators believed was real, a structured universe centered on their sacred city. The Polynesian stick charts sit in museum cases, their shells and sticks arranged in patterns that once guided voyagers across the largest ocean on Earth. These documents share nothing except their capacity to surprise us, their refusal to fit neatly into the narratives we've constructed about the development of geographical knowledge. They are anomalies, exceptions, liminal objects that occupy the boundaries between what we understand and what we cannot explain. They may all have prosaic explanations that future research will reveal. They may preserve fragments of knowledge whose origins we will never trace. They may be coincidences, lucky guesses, the statistical outliers that any sufficiently large sample will produce. Or they may be evidence of something else, something that our current understanding cannot accommodate, something that waits in the archives for the moment when we develop the conceptual tools to recognize what we are seeing. The questions remain open. The maps remain patient. The surface of the Earth continues to reveal its secrets slowly, reluctantly, through technologies that would have seemed magical to the cartographers whose work we have examined. And somewhere in the correspondence between ancient documents and modern surveys, in the precise alignment between depicted coastlines and confirmed topography, in the uncanny accuracy that exceeds what the available tools should have permitted, somewhere in that correspondence, a mystery persists. It is a mystery about the nature of human knowledge, about the transmission of information across time, about the possibility that our ancestors knew more than we have credited them with knowing, or that the sources of their knowledge remain hidden from us, buried like Antarctic coastlines beneath accumulated layers of time. The journey through impossible cartography has not answered these questions. It has only demonstrated that they deserve to be asked, that the anomalies are real even if their explanations remain elusive, that the maps speak to us across centuries with voices whose origins we cannot identify. They invite us to continue looking, continue questioning, continue seeking the sources of knowledge that should not exist yet manifestly does. The shells in their matrix of sticks, the ink on Renaissance parchment, the carved notations on ancient papyrus, the incised lines on Babylonian clay, all these materials have preserved information that their creators encoded, information that we can read but cannot fully explain. The silence of the maps is not empty silence, it is pregnant silence, the silence of evidence that speaks in a language we have not yet learned to translate. We have traced their features, compared their details, noted their correspondences with modern knowledge. We have done what careful scholarship requires, but at the end of examination mystery remains, patient as coastlines beneath ice, waiting for the moment when the ice retreats and reveals what has been hidden all along. The patterns recur across continents and millennia, across cultures that shared no common language, no trade routes, no diplomatic exchanges. They recur with a persistence that cannot be dismissed as coincidence, with a consistency that demands attention even when explanation fails. The Babylonian cartographer who incised his circular cosmos into wet clay could not have known that navigators in the distant Pacific were constructing their own spatial records from materials the Mesopotamian world had never seen. The Polynesian wayfinder who bound shells to curved sticks could not have imagined that scholars in Renaissance Venice were compiling world maps that attempted to encompass the same global surface his charts encoded in miniature. The Egyptian surveyor who traced the gold-bearing wadis of the Eastern Desert could not have conceived of the aerial surveys that would one day confirm the accuracy of his work. Yet all of them engaged in the same fundamental act, the translation of three-dimensional space into portable form, the encoding of geographical knowledge into materials that could be carried, consulted, and passed from generation to generation. The impulse toward cartography appears to be universal, arising independently wherever human beings needed to navigate, to plan, to understand their position within a larger world. What distinguishes the maps we have examined is not the impulse itself, but the precision of its execution, the uncanny correspondence between what these documents depict and what modern technology confirms exists. That correspondence is the thread that binds these disparate cases together, the anomaly that transforms them from isolated curiosities into a pattern demanding interpretation. Consider what we have actually demonstrated across these hours of examination. We have shown that a 16th century Ottoman admiral possessed source materials depicting Antarctic coastlines that would not be surveyed for another 4 centuries. We have shown that a Venetian family's collection included charts of Greenland, revealing subglacial topography invisible to any observer who lacked ground-penetrating radar. We have shown that a French geographer drew Antarctica as 2 distinct landmasses nearly 200 years before seismic surveys confirmed the division. We have shown that a piece of parchment, authentic or forged, depicts a North American landform with remarkable geographical accuracy. We have shown that a Venetian monk compiled information about the Indian Ocean that European navigators would not confirm for decades. We have shown that Egyptian mining engineers produced geological surveys accurate enough to guide modern prospectors. We have shown that Babylonian priests encoded cosmological concepts sophisticated enough to anticipate features of later astronomical understanding. We have shown that Pacific Islanders developed navigational instruments capable of crossing thousands of miles of open ocean with a reliability that European mariners could not match until they possessed chronometers. Each case stands independently, documented through artifacts that survive for examination, verified through comparison with modern data, analysed by scholars whose credentials are not in question. The conventional explanations for each case are not unreasonable: coincidence, interpolation, later alteration, lucky guessing, access to sources now lost. These explanations satisfy the requirements of methodological caution, the healthy skepticism that protects scholarship from credulity. And yet, taken together, the cases compose a pattern that the individual explanations do not address. The pattern is this: across cultures that had no contact with one another, separated by oceans and millennia, human beings produced geographical documents of startling accuracy, documents that depict features their creators should not have been able to observe, features that correspond with modern surveys conducted using technologies the ancients could not have imagined. The mainstream explanation for each individual case does not explain the recurrence of the phenomenon across such diverse contexts. If Piri Reis was simply lucky in his interpolation, why were the Polynesians also lucky in their wave pattern analysis? If the Turin Papyrus reflects only skilled surveying within the capabilities of New Kingdom Egypt, why does the Babylonian world map reflect equally sophisticated spatial thinking from a completely different tradition? If Ramaro simply had access to now-lost Portuguese reports, why did Filipe Boache have access to now-lost Antarctic data? The individual explanations do not speak to one another because they are designed to address individual cases. But the cases are not truly individual. They are instances of a recurring phenomenon, and the phenomenon itself demands an explanation that the case-by-case approach does not provide. One possibility is that human cartographic ability is simply more sophisticated than we have credited. Perhaps the capacity to observe, to measure, to encode spatial information accurately is a fundamental human capability that various cultures have independently developed to high levels of precision. This explanation has the virtue of simplicity. It does not require us to posit lost technologies, unknown contacts, or anomalous sources of information. It asks only that we revise our assumptions about what human beings can accomplish with the tools and techniques available to them. The Polynesian stick charts support this interpretation strongly. Their creators accomplished navigational feats using methods that differ entirely from European techniques, but prove equally effective. They did not need compasses or sextants or chronometers because they had developed alternative methods for reading the ocean, methods that required generations of accumulated knowledge, certainly, but methods that remained within the boundaries of what skilled observation and spatial intelligence can achieve. If Pacific Islanders could navigate the open ocean by reading wave refraction patterns, perhaps other cultures could map distant coastlines by methods we have not yet identified, methods that left no traces except the maps themselves. But this explanation, satisfying as it is, encounters difficulties when pressed. The Polynesian methods, however sophisticated, required direct experience of the sea. Navigators learned by sailing, by observing, by developing the perceptual skills that allowed them to read swells and currents. The knowledge was empirical, built up through countless voyages, transmitted through apprenticeship and practice. It was not theoretical knowledge that could be deduced from first principles. It was practical knowledge that could only be acquired through direct engagement with the environment being mapped, and this is precisely what makes the Piri Reis map so puzzling. Antarctic coastlines cannot be observed from Ottoman ships. Greenland's subglacial topography cannot be seen by any observer standing on the surface. The features that these maps depict were not available for empirical observation, no matter how sophisticated the observational techniques employed. Something more than skilled observation must account for their presence on parchment and paper. The conventional response to this difficulty is source criticism. Piri Reis claimed to use ancient source maps. The Zeno family claimed to possess documents from 14th century voyages. Philippe Boisch claimed to extrapolate from existing geographical data. In each case, the cartographer himself provides a potential explanation. He did not observe these features directly, but copied them from earlier documents that have since been lost. This explanation is entirely plausible. Documents are lost constantly. The survival of any ancient text is the exception rather than the rule. The Great Library of Alexandria contained hundreds of thousands of scrolls, of which almost none survive. Medieval monasteries copied classical texts selectively, preserving some while allowing others to decay into illegibility. Every archive, every collection, every repository contains only a fraction of the documents it once held. The possibility that ancient cartographic knowledge survived in documents that were subsequently lost is not merely plausible, it is almost certain. The question is not whether such documents existed, but whether they could have contained the information that later cartographers appear to have accessed. And here the mystery deepens rather than resolving. If Piri Reis's source maps depicted Antarctic coastlines accurately, where did those source maps obtain their information? The problem has not been solved. It has simply been pushed back one step. An ice-free Antarctic coast has not existed for thousands of years, long before any civilization that we recognize as capable of cartography had emerged. If the coastline depicted on the Piri Reis map represents Antarctica before the ice, then the information predates not merely the Ottoman Empire, not merely the classical world, but the entire span of recorded history. The source maps that Piri Reis consulted would themselves require sources, and those sources would require sources before them, the chain of transmission extending backward into a past so deep that our categories of historical analysis cease to apply. We are accustomed to thinking of cartography as a product of civilization, of writing, of the complex social organization that allows specialized knowledge to be recorded and preserved. But if Antarctic coastlines were mapped before the ice accumulated, then cartography preceded civilization as we understand it, emerging from a period about which we know almost nothing, a period whose cultural productions, if they existed, have left no traces except, perhaps, anomalous details on Renaissance maps. This is the precipice that careful scholarship approaches and from which it wisely retreats. The implication is too vast, too destabilizing, too far removed from everything we think we know about human history. It is easier, safer, more methodologically responsible to conclude that the correspondences are coincidental, that the accuracy is overstated, that the interpretations are forced, and these conclusions may be correct. The responsible scholar does not leap to extraordinary claims when ordinary ones remain available. The responsible scholar maintains skepticism, demands evidence, applies Occam's razor to explanations that multiply entities beyond necessity. The responsible scholar recognizes that anomalies are often anomalies only until better information becomes available, that yesterday's mystery is frequently today's solved problem, that the history of science is littered with phenomena that seemed inexplicable until their explanations became obvious. Yet the anomalies we have examined do not resolve themselves. The Piri Reis map has been studied for over 90 years, and the debate about what it depicts continues. The Boisch map was drawn nearly 3 centuries ago, and the correspondence between its divided Antarctica and the confirmed subglacial topography has grown stronger, not weaker, as survey data has accumulated. The Zeno map remains contested, but the features it depicts continue to match radar soundings conducted centuries after its creation. These are not anomalies that dissolve under scrutiny, they are anomalies that deepen, that become more puzzling as our knowledge increases rather than less. The more precisely we can map the features they depict, the more remarkable their accuracy becomes. The better we understand the technologies available to their creators, the more difficult it becomes to explain how those creators obtain the information their maps contain. Time does not resolve these mysteries. Time sharpens them, adding weight to questions that remain unanswered despite decades, sometimes centuries, of investigation. The Polynesian stick charts offer a different kind of evidence that complicates rather than clarifies. They demonstrate that non-Western peoples developed cartographic techniques of extraordinary sophistication, techniques that Western observers initially dismissed as primitive, but eventually recognized as functionally superior for their intended purpose. They demonstrate that knowledge can be encoded in forms that outsiders cannot read, that cartographic traditions can develop independently and in parallel, that the history of map-making is far richer and more diverse than the European tradition alone would suggest. But they also demonstrate that some forms of knowledge leave no documentary traces. The Polynesian navigators did not write treatises explaining their methods. They did not compile archives of instructional materials. They passed their knowledge from master to apprentice through direct training, through observation and imitation and countless hours on the water. When the chain of transmission broke, when colonization disrupted traditional societies, when young people stopped apprenticing to master navigators, when the voyaging canoes ceased their journeys, the knowledge itself began to vanish. What survives is fragmentary, reconstructed by modern researchers working with the few remaining practitioners and the physical artifacts that ended up in museum collections. If similar knowledge once existed in other cultures, if ancient Mediterranean peoples possessed navigational techniques that have since been lost, if civilizations unknown to history developed cartographic methods whose products survive only as anomalous details on later maps, we would have no direct evidence of their methods, only the maps themselves, speaking in languages we cannot translate. This is the haunting possibility that the anomalous maps suggest. Not necessarily lost civilizations in the dramatic sense, not Atlantis or Lemuria or the fanciful continents of 19th century occultism, but simply lost knowledge, lost techniques, lost chains of transmission that once carried information we can no longer trace to its source. The medieval European monks who copied classical texts did not always understand what they were copying. They preserved words whose meanings had been forgotten, diagrams whose significance had been lost, references to works that no longer existed. The information passed through their hands like water through a sieve, some drops retained, most lost forever. If geographical knowledge followed the same pattern, if ancient maps were copied by scribes who did not fully understand them, who simplified details that seemed insignificant, who preserved outlines without preserving the observational methods that produced them, then the source of the knowledge would become untraceable, even as the knowledge itself survived. We would be left with anomalous accuracy and no explanation for its presence, with maps that depict features their official creators could not have observed, with correspondences that defy the conventional chronology of discovery. The implication extends beyond cartography. If geographical knowledge could survive in this fashion, transmitted, corrupted, preserved in fragments, its origins forgotten, then other forms of knowledge might follow the same pattern. The ancient world knew techniques that the medieval world forgot, and the modern world rediscovered. Roman concrete lasted centuries longer than modern concrete because it incorporated volcanic ash whose properties we're only now beginning to understand. Damascus steel possessed qualities that modern metallurgists could not replicate until they analysed surviving blades at the molecular level. Greek fire was a military technology so secret that its formula was lost when the Byzantine Empire fell, and modern reconstructions remain uncertain. In each case, knowledge existed, was applied, proved effective, and then vanished from the record, leaving behind only products whose manufacturing techniques had to be reverse engineered by modern researchers. If practical technologies could be lost so completely, why not geographical knowledge? Why not observational data, surveying techniques, measurement methods whose products survive even though the methods themselves have been forgotten? The Fra Mauro map offers a partial glimpse of how such transmission might have worked. The Venetian monk compiled information from multiple sources: Portuguese navigators, Arab geographers, classical texts, oral reports from travellers. He did not observe the coastlines he depicted. He assembled reports, evaluated their reliability, reconciled their contradictions, and produced a synthesis that represented his best understanding of the world's geography. His sources are partially known, but many remain unidentified. He may have had access to reports that have since been lost, to informants whose testimony was never written down, to documents that did not survive the centuries between his time and ours. His map depicts features that European navigators would not confirm for decades, not because Fra Mauro possessed supernatural knowledge, but because he had access to sources that have not survived. The map preserves information whose original documentation has been destroyed, transmitted through a chain of copying and compilation whose earlier links are now invisible. Scale this phenomenon across centuries. Imagine Fra Mauro's map being copied by a scribe who did not know where the information came from. Imagine that copy being used as a source by a later cartographer who assumed the information was original to the earlier map. Imagine the chain of transmission extending backward and forward, each link preserving some information while losing the provenance that would explain its presence. After enough generations, the original observations would be untraceable, the information floating free of its sources, accurate but inexplicable. This is how knowledge can become mysterious without being mystical, how ordinary processes of transmission and loss can create anomalies that seem to demand extraordinary explanations. And yet this process of ordinary transmission does not fully account for what we observe. Fra Mauro's accuracy is impressive but explicable. He had access to contemporary Portuguese navigation, to Arab geographical scholarship, to the accumulated knowledge of medieval trade networks. The information he synthesized was current or nearly current, produced by observers whose methods and capabilities we understand. The anomaly of the Piri Reis map is of a different order. If its Antarctic coastline is accurate, the information predates the ice, predates civilization, predates the emergence of writing itself. No chain of ordinary transmission, however long, can connect Ottoman Constantinople to an Antarctica that has been ice-covered for millennia. Either the correspondence is coincidental, or the information comes from a source outside the boundaries of conventional history. The same logic applies to the Boache map's divided Antarctica, to the Zeno map's subglacial Greenland, to any cartographic depiction of features that were not observable at the time of the map's creation. If the accuracy is real, not imagined, not exaggerated, not the product of wishful interpretation, then the information requires a source. If the source is not observable features, it must be earlier documents. If those earlier documents depicted features that were also not observable at the time of their creation, they too must have had sources. The chain extends backward, link by link, toward an origin that recedes perpetually into the past, always demanding an earlier explanation that is never provided. At some point, the chain must begin. At some point, someone must have observed the features that appear on the later maps. And if those features were not observable within the span of recorded history, then the observer, whoever they were, predates the history we think we know. This is speculation, not conclusion. The responsible position remains that the correspondences are coincidental, or that the interpretations are flawed. The alternative, that the maps preserve knowledge from sources we cannot identify, sources that may predate conventional chronologies of human capability, is not a claim that can be proven with the evidence available. It is a possibility that the evidence permits, a hypothesis that fits the data without contradicting known facts, but a hypothesis that lacks the direct confirmation that would transform it from speculation into established knowledge. The maps themselves cannot tell us where their information came from. The source documents that Piri Reis claimed to consult have not survived. The surveys that might have produced the Boache map's Antarctic coastline, if such surveys ever existed, left no trace. The Venetian voyages described in the Zeno narrative remain unconfirmed. The ancient observations that might underlie the Turin Papyrus, the Babylonian world map, the unknown source materials for countless later compilations, all these potential origins have been erased by time, leaving behind only the enigmatic products of unknown processes. What remains is the question itself, persistent and unanswered, recurring across every case we have examined. How did they know? The question has been asked of the Piri Reis map for nearly a century. It has been asked of the Polynesian navigators since the first European observers recognised what their voyages accomplished. It has been asked of every map that depicts features its creators should not have been able to observe, every artefact that encodes knowledge beyond the apparent capability of its culture. The question does not age because it does not resolve. New techniques, new surveys, new methods of analysis. Each generation adds precision to our understanding of what the maps depict. and each addition of precision makes the original question more pressing. The correspondences become tighter as our measurements become better. The accuracy that seemed remarkable becomes extraordinary, and the extraordinary becomes inexplicable, and the inexplicable remains, waiting for an explanation that scholarship has not yet provided. The night deepens over museum archives where these documents sleep in climate-controlled cases. Conservators have stabilized the materials as best they can, protecting parchment and papyrus and clay from the slow decay that claims all physical objects. The maps will last for centuries more, barring catastrophe, their enigmas preserved along with their pigments and their substrates. Future generations will study them with technologies we cannot imagine, discovering details invisible to present instruments, perhaps unlocking patterns that our analytical methods cannot detect. The Piri Reis map will be scanned, digitized, analyzed by algorithms that have not yet been written. The stick charts will be modeled in 3 dimensions, their shell and stick encoding translated into mathematical representations that preserve every nuance of their spatial logic. The Turin Papyrus will be examined at the molecular level, its mineral pigments traced to their geological sources with isotopic precision. Each advance in technology will generate new data, new measurements, new correlations that shift the scholarly consensus in directions we cannot predict. But the fundamental question will persist. The technology of analysis, however advanced, cannot answer a question about sources when the sources themselves have been lost. The most detailed scan of the Piri Reis map cannot reveal where Piri Reis obtained his information. The most sophisticated wave modelling software cannot tell us how Polynesian navigators developed their empirical understanding of ocean physics. The most precise spectroscopic analysis of the Turin Papyrus cannot identify the surveyors who walked the eastern wadis and recorded what they observed. The maps are artifacts of processes that left no other traces, endpoints of transmission chains whose earlier links have vanished. They are messages in bottles whose originating shores have sunk beneath the waves. They are voices without bodies, speaking in languages partially comprehensible, delivering information whose origins they do not reveal. The mystery is built into their nature as historical documents. They preserve what they preserve, and everything they do not preserve, the methods, the observations, the surveying expeditions, the generations of accumulated knowledge, has been lost. And perhaps that loss is itself the message. Perhaps the vanishing of origins is not an accident of historical preservation, but a pattern so consistent that it demands interpretation. Consider the breadth of what we have examined. A Turkish admiral compiling sources in the 16th century, drawing coastlines that would not be surveyed for 400 years. Venetian merchants describing islands beneath glacial ice, their charts matching radar topography completed in the 20th century. A French geographer publishing a southern continent in 1737, its rivers and inland seas invisible beneath kilometres of frozen water until satellite imaging revealed them 2 centuries later. A Norse voyage captured on parchment that scholars cannot authenticate, its very existence suspended between forgery and discovery. A Venetian monk assembling the knowledge of the known world in his monastery cell, recording distances and relationships that exceed the sum of his declared sources. An Egyptian scribe painting a geological map on papyrus, marking gold deposits and rock formations with a precision that modern surveyors struggle to improve upon. A Babylonian priest inscribing the cosmic order on a clay tablet, positioning mythological regions according to a geometry that requires theoretical frameworks not formalized for millennia. And Polynesian navigators crossing the largest ocean on Earth, their stick and shell charts encoding wave physics that Western science would not mathematically describe until the modern era. 8 cases, 8 cultures, 8 historical periods, 8 completely different cartographic traditions, and the same pattern repeating across all of them. Knowledge that exceeds apparent capability. Precision that survives comparison with modern surveys. Sources that vanish without explanation. Methods that leave no traces. The pattern is too consistent to be coincidence. It recurs across millennia, across continents, across civilizations that had no contact with one another. The Babylonians knew nothing of the Polynesians knew nothing of the Turks knew nothing of the Venetian monks, or rather knew only what filtered through the official channels of Mediterranean commerce and diplomacy, nothing that would explain the anomalies in their respective maps. Each culture developed its cartographic traditions independently, drew upon its own sources, served its own purposes, encoded its own understanding of spatial relationships. And yet, when modern analysts examine their products, the same questions arise. The precision is too high, the knowledge is too complete, the sources are too invisible. Something is missing from the historical record, some factor or process or tradition that would explain how these artifacts came to contain what they contain. The conventional responses to this pattern are well established. For each case, mainstream scholarship offers an explanation. Coincidence, extrapolation, lucky guesswork, lost source documents within known historical traditions. The compounding of small observations over generations until the accumulated result exceeds the sum of its individual parts. These explanations are not unreasonable. They respect the methodological principles that guide historical inquiry. They avoid invoking unknown factors when known factors might suffice. They maintain the coherence of the established timeline, the accepted understanding of technological development, the conventional model of how knowledge accumulates and transmits across cultures and centuries. But they share a common characteristic. They all require something to have happened that left no evidence of happening. They require sources that have vanished completely. They require transmission chains that have been entirely erased. They require processes of accumulation that occurred without anyone recording them, methods of observation that were practiced without anyone describing them, surveys that were conducted without anyone documenting them. The conventional explanations, in other words, depend upon the same appeals to lost knowledge that they dismiss as speculation when proposed by alternative theorists. The difference is only in the nature of the knowledge that is presumed lost. The mainstream scholar says, the knowledge came from sources within known traditions, and those sources have been lost. The alternative theorist says, the knowledge came from sources outside known traditions, and those sources have been lost. Both invoke absence, both point toward gaps in the historical record. Both acknowledge that the artifacts themselves cannot explain their own origins. The disagreement is not about whether something is missing from the historical record. On that point, all sides agree. The disagreement is about what that missing something might have been. And standing amid that disagreement, the maps themselves remain silent. They do not advocate for their own origins. They do not provide the context that would resolve the debates that surround them. They simply are what they are, physical objects bearing spatial information, created at particular moments by particular hands, surviving into the present through the accidents of preservation, while the traditions that produced them were disrupted. The source documents that informed them were destroyed. The methods that gathered their data were forgotten. The gazelle skin parchment of the Piri Reis map has no voice to tell us where its Antarctic coastline originated. The shell and stick assemblages of Polynesian navigation have no mechanism to explain how their creators understood wave refraction. The papyrus of the Turin geological map cannot describe the surveys that generated its accuracy. Each artifact preserves a final product, while the process that created it has been erased. This is not unique to cartography. It is the condition of historical knowledge more broadly. We possess the artifacts of the past without possessing the full context of their creation. We have the poems of Homer without knowing how they were composed. We have the pyramids of Giza without knowing precisely how they were constructed. We have the bronze statues of classical Greece without knowing all the techniques of their casting. Every surviving object from the ancient world is to some degree orphaned from its origins. The maps we have examined are simply more dramatic examples of a universal problem. They display knowledge that seems particularly difficult to explain given their historical contexts, but in this they differ only in degree from countless other artifacts that raise questions about the capabilities of their creators. What makes the cartographic anomalies distinctive is their testability. A poem cannot be checked against the reality it describes, not in any precise way. A statue cannot be measured against the model it depicts, not when the model has been dead for millennia. But a map can be compared to the territory it represents. The lines drawn on parchment or encoded in shell arrangements can be overlaid upon satellite imagery, bathymetric surveys, ice-penetrating radar data. The correspondences can be quantified, the accuracy can be measured, the anomalies can be expressed in percentages and statistical probabilities. This testability is what makes the cartographic mysteries so persistent. It is not merely a subjective impression that the maps seem too accurate. The accuracy can be demonstrated through methods that any competent analyst can replicate. The Piri Reis map's coastline does correspond to the subglacial topography of Antarctica. at a level of detail that peer-reviewed studies have documented. The Zeno map's Greenland does match ice-penetrating radar surveys at points where the conventional explanation would not predict correspondence. The Boache map's Antarctic interior does show features, rivers, inland bodies of water, that satellite imaging has confirmed beneath the ice. The Turin Papyrus does locate geological features with precision that modern surveys validate. The Polynesian stick charts do model wave physics that oceanographers have mathematically described only in recent decades. These are not matters of interpretation, they are matters of measurement, and the measurements generate questions that interpretation has not resolved. The night continues over the scattered locations where these artifacts reside. In Istanbul, the Piri Reis map sleeps in its conservation case at Topkapi Palace. The gazelle skin parchment protected from light and humidity. The Antarctic coastline waiting to be examined by the next generation of analysts. In museum collections across Europe and Oceania, Polynesian navigation charts rest in display cases or storage drawers, their shell and stick structures largely divorced from the living traditions that created them, the navigators who could read them having passed on their knowledge to only a handful of successors. In the Egyptian Museum in Turin, the papyrus map of the Wadi Hammamat lies in its climate-controlled storage, its mineral pigments stabilised against further fading, its geological precision preserved for future study. The British Museum holds its Babylonian clay tablet, the cosmic diagram inscribed upon it, still raising questions about its cosmological implications. The Biblioteca Nazionale Marziana in Venice holds the Fra Mauro Mappamundi, its thousands of annotations still offering insights to scholars patient enough to parse its medieval Latin. Wherever these objects rest, they carry their mysteries with them. They are not dead things, not mere artifacts of historical interest. They are active questions, unresolved puzzles, ongoing challenges to scholars who attempt to understand how the past knew what it knew. Every generation that studies them adds new tools, new methods, new comparative data, and every generation finds that the questions remain, that the anomalies persist, that the explanations offered by previous generations have not quite closed the case. Perhaps closure is not the appropriate goal. Perhaps the maps are valuable precisely because they resist final interpretation. They function as reminders of what we do not know, counterweights to the confidence that can accumulate when a discipline feels it has mastered its subject. Archaeological and historical scholarship have made extraordinary progress over the past 2 centuries. The methods of the field have been refined, the databases of evidence have been expanded, the analytical technologies have advanced beyond what earlier generations could have imagined. The past is more accessible now than it has ever been. We can reconstruct ancient climates from ice cores. We can trace ancient migrations through genetic analysis. We can date organic materials through radiocarbon measurements. We can identify trade networks through isotopic fingerprinting of metal artifacts. We can detect buried structures through ground-penetrating radar. We can reconstruct lost texts through multispectral imaging. The toolkit of modern scholarship is vast and growing, and its application has transformed our understanding of human history. But the maps we have examined remind us that the toolkit has limits. Some questions cannot be answered by analysing the artifacts themselves. Some processes leave no traces that any instrument can detect. Some knowledge is lost completely, leaving behind only its products without any evidence of how those products were created. The anomalous maps are windows into this fundamental limitation. They show us knowledge that existed but cannot be explained, precision that was achieved by methods we cannot reconstruct, understanding that was developed through processes we cannot trace. They are monuments to lost capability, whatever that capability might have been, and they invite us to humility. The conventional assumption that technological and scientific capability has followed a linear progression from past to present is not wrong exactly, but it is incomplete. It captures the broad trend while missing the local reversals. The Romans understood concrete chemistry that was lost for centuries after their empire fell. The medieval smiths who forged Damascus steel achieved metallurgical results that modern engineers have only recently learned to replicate. The Greeks built mechanical computers that had no successors for 2 millennia. The Polynesians developed navigational techniques that Western science could not match until satellite technology became available. In field after field, culture after culture, the historical record preserves evidence of capabilities that were achieved, flourished briefly or for centuries, and then vanished. leaving behind artifacts that subsequent generations could admire but not reproduce. The anomalous maps may be further examples of this pattern. They may preserve the products of surveying traditions, observational methods, accumulated knowledge bases that flourished in contexts we can barely imagine, and then disappeared, erased by conquest or climate change or cultural disruption, leaving behind only the maps themselves, orphaned from the traditions that gave them birth. This is not a mystical interpretation. It is not an appeal to lost civilizations with advanced technology. It is simply an acknowledgement that knowledge can be lost, that techniques can be forgotten, that methods can vanish when the cultures that practiced them are disrupted. The historical record is not a complete archive of human capability. It is a fragmentary survival, shaped by the accidents of preservation, biased toward those cultures whose writing systems we can decode and whose materials resist decay. What has been lost is almost certainly greater than what has survived, and within that vast lost archive, there may well have been sources, written or oral, formal or practical, ancient or merely old, that inform the maps we have examined, sources that would explain everything, sources that no longer exist. The night passes toward dawn over the scattered archives where the maps reside, and the questions remain. They have remained for centuries, growing neither weaker nor stronger, neither closer to resolution nor more remote. The Piri Reis map was rediscovered in 1929, and the debate over its Antarctic coastline began almost immediately and has not ended. The Polynesian navigation traditions were first documented by European observers in the 18th century, and the scholarly wonder at their sophistication has continued unabated ever since. The Turin Papyrus was acquired by the Italian consul in 1824, and its remarkable accuracy has been noted by every generation of scholars who have studied it. The Babylonian world map has been examined continuously since its discovery in the 19th century, and its theoretical implications remain contested. Each generation brings new tools, new questions, new interpretive frameworks, and each generation finds that the central mysteries persist. The maps do not yield their secrets to closer study. They merely become more detailed in their refusal to explain themselves. There is a particular quality to a mystery that will not resolve. It creates a space in consciousness, an opening that remains open, a question that does not close. The mind returns to it, worrying the edges, probing for weaknesses, seeking the key that will unlock the puzzle. But some puzzles have no keys. Some locks have no mechanisms to pick. Some doors are not doors at all, but merely painted images of doors on solid walls. The anomalous maps may be such painted doors. They may present the appearance of mystery while having perfectly mundane explanations that we simply lack the evidence to confirm. The correspondences between the Piri Reis map and the subglacial coastline may be coincidental, the result of educated guesswork that happened to match reality. The Polynesian wave charts may encode knowledge that any culture could develop, given sufficient time and motivation on the open ocean. The Turin Papyrus may simply represent excellent local knowledge, the accumulated observations of Egyptian miners who walked those weeders for generations. Each anomaly may have its own conventional explanation, and the pattern we perceive across them may be nothing more than the human tendency to find patterns where none exist. This is possible. It is even by certain measures probable. The principle of parsimony counsels us to prefer simple explanations over complex ones, and the simplest explanation for a series of cartographic anomalies may be that they are not anomalies at all, merely artifacts that we have studied with insufficient context and interpreted with excessive wonder. But standing in the archives at dawn, watching light creep across the cases where the maps rest, one cannot help but feel that the conventional explanations explain everything while illuminating nothing. They account for the facts while missing the mystery. They describe how the maps might have been made while failing to capture what it means that they were made. The Piri Reis map is not merely an artifact of 16th century Ottoman cartography. It is a message from a world where someone knew what the Antarctic coastline looked like before any recorded voyage reached those shores. The Polynesian stick charts are not merely ethnographic curiosities. They are embodiments of a navigational tradition that crossed the largest ocean on Earth using knowledge that Western science would not formalize for centuries. The Turin Papyrus is not merely a bureaucratic document from ancient Egypt. It is evidence that someone, 32 centuries ago, walked the desert wadis and recorded what they observed with accuracy that modern surveys struggle to improve upon. Each map is a trace of human capability, a record of knowledge that once existed, a window into minds that understood something about the world that they could encode in physical form and transmit across generations. That knowledge, whatever its sources, is impressive. It commands respect. It suggests that the past was more capable than we often assume, that the ancestors knew more than we credit them, that there were traditions of observation and measurement and accumulated wisdom that flourished in contexts we can barely imagine, and then vanished, leaving behind only these orphaned documents, these messages in bottles, these voices without bodies speaking across the centuries. The dawnlight strengthens over Istanbul, over Venice, over Turin and London, and the scattered islands of Polynesia. The museums open their doors, the scholars return to their research, the tourists file past the display cases, glancing at the ancient documents behind glass, rarely pausing long enough to consider what they represent. The maps wait, patient as they have waited for decades or centuries, holding their information in forms that resist final interpretation. They are not secrets waiting to be uncovered. They are mysteries that have been examined and re-examined without resolution. They are questions that do not age because they do not resolve. They are invitations to humility, reminders that the past is larger than our knowledge of it, that capability can be achieved and lost, that traditions can flourish and vanish, that the surviving fragments of ancient knowledge may be the barest portion of what once existed. The Turkish admiral poring over his source documents in 1513, the Polynesian navigator teaching wave patterns to an apprentice on a Pacific beach, the Egyptian scribe laying mineral pigment on papyrus in the desert heat, the Babylonian priest inscribing cosmic order on wet clay. All these figures have left traces that endure, records that survive, mysteries that persist. They knew something. They encoded what they knew. And the encoding has lasted while the knowledge itself has been lost. What secrets remain, sleeping in archives, encoded in materials we have not yet examined, preserved in forms we do not yet know how to read? The maps we have studied are only those that have been recognized, catalogued, brought to scholarly attention. How many others rest in private collections, in unexplored archives, in the holdings of institutions that have not catalogued their materials? How many have been lost entirely, burned, decayed, destroyed in wars and floods and fires, taking their encoded knowledge with them into oblivion? The cartographic record that survives is surely incomplete. The anomalies we have examined are surely only a portion of the anomalies that once existed. If we could recover every map that was ever made, every chart that was ever drawn, every spatial representation that any human culture ever created, what patterns might we find? What correspondences might emerge? What questions might intensify? The surviving fragments are already remarkable enough. The lost archive must have been extraordinary. The light fills the cases now, illuminating parchment and papyrus and clay and shell. The maps glow in their protective environments, their pigments stable, their surfaces preserved, their information intact. They will last for centuries more if properly conserved. Future generations will study them with technologies we cannot imagine, finding details invisible to us, detecting patterns we cannot perceive. Perhaps those future scholars will finally close the cases we have examined, explaining definitively how each map came to contain what it contains. Perhaps they will discover the lost sources, recover the vanished traditions, reconstruct the methods that left no traces. Perhaps the anomalies will resolve into ordinary history, extraordinary only in the magnitude of what was accomplished, not in the mystery of how it was accomplished. Or perhaps the questions will persist. Perhaps every advance in analytical technology will only deepen the mystery, as every improvement in survey accuracy has deepened it so far. Perhaps the maps will continue to pose questions that scholarship cannot answer, inviting each generation to wonder, to speculate, to imagine the capabilities that might have existed in eras we call ancient. Perhaps the mystery is itself the point, the enduring gift that these artifacts offer, the reminder that the past exceeds our knowledge, that the ancestors achieved more than we can document, that there are traces of capability and understanding preserved in forms that invite our study while resisting our final interpretation. The maps remain. The questions persist, and in the space between what we know and what we cannot know, there is room for wonder, the wonder that draws scholars to archives and tourists to museums, the wonder that keeps the ancient questions alive, the wonder that recognises in these fragile documents the traces of minds that grasped something true about the world and found ways to encode it, ways that survived when everything else about their traditions vanished. The cartographic anomalies are monuments to that survival. They are evidence that some knowledge endures, even when the cultures that created it are disrupted, even when the sources that informed it are destroyed, even when the methods that generated it are forgotten. The knowledge endures because it was made physical, because it was encoded in materials that resist decay, because someone cared enough to write it down or weave it into shell and stick. And in enduring, it poses questions that may never be answered, questions that refresh themselves with every generation, questions that will persist as long as the maps themselves persist. The night has passed over the world's archives, and the maps have survived another darkness. They will survive many more. And long after the current debates have been superseded, long after the current scholars have retired, long after the current technologies have been replaced by methods we cannot imagine, the fundamental question will remain, echoing across centuries as it has already echoed, patient as stone, persistent as the sea. How did they know?